Hello, my dear students. I welcome you to this amazing platform of PhysicsWallah English. So, guys, today's in Champions Crash course, we are going to do matrices and determinants. If you talk about weightage of this chapter, you are going to have close to 2 or 3 problems in JEE main. The good thing is with this chapter is that matrix questions are extremely based on some pattern. You will see the questions are being repeated over and over and again. Like in from matrices, you will see one type of question where we have a matrix given and you have to talk about the higher power of it. Like if there is a matrix A given, you have to do something with A power 30, A power 40, or maybe like some greater or lesser power. So what we do, we just do the multiplication. We try to find the pattern and then we solve the problem. So this is one type which you will keep on getting. The second type where you have a problem based on properties of determinants, and that is extremely easy. Even in NCERT, the type of determinants given, if you have practiced them, you will feel a little bit confident about the questions in JEE main also. Then the third segment, which is getting asked a lot, is questions from inverse and adjoint. Right, the properties of adjoint and inverse together. There you have simple problem, including properties of determinant also. And the fourth section, that is very the frequent over these 10-12 years, that is Cramer's rule. You see, every year you are going to have one question from Cramer's rule. That is a segment which is definitely going to be there in your paper. And there are only two to three concepts. You do them and you will get them correct. We'll see them in today's session. So guys, today I won't be dealing with theory too much. I'll just show you that what exactly are there. Okay, I'm not going to explain too much like other classes. Few parts of the theory which is difficult for everyone to understand, that I'll try to explain. Otherwise, I'm just going to show you that what are the theoretical parts. Theory you have to do on your own. We'll be solving some PYQs. I don't want to make this lecture lengthy. Okay. Starting with definition. In this definition, what is important for you to know is the trace. Like what is trace of any matrix? So trace will be the sum of diagonal elements. A11, all these. Like this is all the diagonal elements. What are diagonal elements? When you have an element of the form A, right? This is the diagonal element. So the sum of all the diagonal elements will be equal to, that will be the trace of matrix A. There are some simple properties that trace of A plus B is trace of A plus trace of B. Trace of A minus B is also the same thing, right? And how do we represent this matrix? This is M rows and column. You can see first row, second row, third row, and this is mth row, and this is nth column. So M by N, row by column, is the order of matrix. Then moving on. Row matrix if you have only one row, column matrix if you have only one column, zero matrix if all the elements are zero. If all the elements are zero, that is called zero matrix. Okay. Square matrix, when you have a matrix of the form n cross n, right, the number of rows are equal to number of columns, that is square matrix. Diagonal matrix, if the elements are there in diagonal, rest all elements are zero. You see, these are diagonal elements. We have elements only in the diagonal, rest all elements are 0. And this is how we represent. You see, this is how we represent. When I say diag A11, A22, so that means it is a diagonal matrix of these type, right? And obviously we'll be dealing with them square matrix. Clear? We have elements only in diagonal, rest all elements are 0. Well, I mean non-zero elements. It can be 0 also, but this is the general expression for a diagonal element. Like this, I can write this is diagonal of ABC. So this is understood that this is a 3 cross 3 square matrix where these are the elements in the diagonal. Clear? Scalar matrix, if all the elements in the diagonal, it's a diagonal matrix where all elements in the diagonal are equal. The unit matrix, if all the elements are equal to 1. Right? First it was diagonal, then it was scalar, and after that unit. You see, all three are almost similar, except the difference between unit matrix and the diagonal is that in diagonal elements it is not necessary to be all the elements in the diagonal equal. Here you have to, you see, unit matrix, all the elements will be equal to 1 1 1. That is about unit matrix. Then moving on, upper triangle matrix where all the elements below diagonal, you see, this is the diagonal here. So all the elements below diagonal is 0. This is upper triangle matrix. All the elements below diagonal is 0. And lower triangle matrix where all the elements above diagonal is 0. All the elements above diagonal is 0. You see. Now, this is not to be only for square matrix. It can be for non-square matrix also, you can see. And see, this is a formula for n cross n. For n cross n minimum number of zeros for matrix to be upper triangular or lower triangle, that is given by n into n minus 1 by 2. This we can simplify easily. We can just need to count, right? You just need to count the number of elements below diagonal and just add it up. You'll see. Then when we multiply a matrix by a scalar thing, then all the elements, it gets multiplied by that. You see, if suppose there's a matrix A, which is something like A, B, C, D, this 2 cross 2. So if I multiply by it by some element K, some scalar value K, it will be Ka, Kb, Kc, Kd. Does not need to be square matrix if it is any row or column matrix, let's say ABC. What will be Ka? K will be, all the elements will be multiplied, Ka, Kb, Kc. So you can take constant common only if it is multiplied to all the elements of the matrix, every single element. Then coming up with these 4 special matrix: nilpotent, idempotent, involutory, and orthogonal matrix. You see, nilpotent matrix where A square becomes null matrix, right? The nilpotent is that when A square becomes null, it will be nilpotent matrix. And obviously, if A square is null, the higher powers will be also null. Then idempotent when A square is equal to A, right? And involutory matrix is square matrix where A square is equal to identity matrix. A square becomes equal to identity matrix is involutory matrix, and then orthogonal matrix where A into A transpose is equal to I. A into A transpose or A transpose into A is equal to identity matrix, that is your orthogonal matrix. Equality matrices, if you equate two matrices, obviously the corresponding elements will be equal. The corresponding elements should be equal. Additional matrices, if you have two matrices of the same order, you can add them, and by adding you will add corresponding elements, right? Like A11 will get added of A to A11 of B. So 1 minus 1, 0, minus 1 plus 2, 1. That is what we add. Subtraction matrices, same funda. Then properties of addition and scalar matrix. These properties you can look up on your own. Talking about multiplication matrices, the order is fixed. It is row by column. This is the order, guys. It is row by column. For multiplication of two matrices, it is fixed. This is row by column. And how exactly we multiply? And there is one more thing. Suppose if A is a matrix of order m cross n and B is a matrix of order something n cross p. Only in that case multiplication is possible, right? If these two are equal, so the product AB will be of order m cross p. Right? This is the thing. If A is a matrix of order m cross n and B is of order n cross p, only in that case product will be possible. The product AB will be of the order m cross p. Like, will BA exist in this case? No, because B is n cross p, A is m cross n. So you see these two are not equal. Product AB is possible only if the number of columns of A is equal to number of rows of B. Right? This in the order. Order is very important in multiplication. You see, AB is not always equal to BA. Because here AB is existent, but B is not even existing. So order is very important in product. Now how do we multiply? So let me show you by example. Suppose there is a matrix A, B, C, D. So this is 2 cross 2. Right? So this is 2 here. The number of columns is 2. So if I want to multiply with any matrix, I need to have 2 rows in that. At 2 rows and whatever columns I want. So let's say I want 3 columns. So I want it to be something like this: A, B, C, D. Then this is L1, L2, L3, M1, M2, M3, N1, N2, N3. Right? So how this multiplication will take place? This is 2 cross 2, and this what? How many rows? This I have made 3 cross 3, but this product will not be possible because this is 2 cross 2. I need only 2 rows here, so I need to remove the third row. Now it is fine. This is 2 cross 3. 2 cross 3. Now it is fine because number of columns here is equal to number of rows. So in that order, from left to right, number of rows, number of columns, number of rows, the product will be possible. Let's write the product and you will have the idea. So the product is written in this way. It is row by column. So it is AL1 plus bm1, right? What will be order, guys? Order will be here, you see, 2 cross 3. The order for product will be 2 cross 3. The first one al1 plus bm1, then al2 plus bm2, al2 plus bm2, and the third one ab l3 m3, so al3 plus bm3, al3 plus bm3. Similarly, you can write the other one also with cd. It will be cl1 dm1, cl2 dm2, cl3 dm3. So this is about product of matrices. It's possible only if we have number of rows equal to number of column for the number of column for one is equal to number of rows of the other one. Okay, you are already aware of it. So let's see some properties. Now some properties of this is extremely important, starting with this, that if you have AB into C given, don't disturb the order. It should be all be ABC. There you can change BC first and then A, or AB into C, but the order should not be disturbed. AB and BA need not to be always equal, right? AB and BA will not be always equal, you have seen. The next is that there is an identity matrix you have read. So product of any matrix, any square matrix with this matrix A will be equal to I, given that product is possible. It's not like that you are taking identity matrix of order 2 cross 2 and A is a matrix of order 3 cross 3. No. If that product is possible, in that case, the product AI or IA is always equal to I. For every non-singular. Now non-singular means matrix means where determinant is non-zero. There exists a unique matrix B so that AB is equal to I is equal to BA. Obviously, we are talking about the inverse here. Okay. Lambda is like this, A into B, C, here. This is pre-multiplication, this is like post-multiplication. So here A is pre-multiplied to B and C, so it is AB, AC. You cannot just write it as BA plus CA like that, no. Here it is AC plus BC, because C was post-multiplied, so AC plus BC, right? One important result is missing here, and that is if product of two matrices is null, that does not mean A is null or B is null. Remember it. If we are saying that product of two matrices is null, that does not mean at all that A is null or B is null. For example, suppose A is a matrix 1 0 0 1 1 0 0 and B is a matrix which is 0 0 0 2, like this. Now here if you find out A into B, guys, what is that? You see 1 0 0 0, it is 0. Then 1 0, so 1 into 0 0 into 2, it is 0 0 0 0 0. You see product AB is null here, but neither A was null nor B was null. So we cannot have this justification with it, cannot have this conclusion with the product A into B given null. Okay, this does not mean at all that A is null or B is null. Clear? So all these properties, guys, all these properties are important. I want you to write one more here. See, you have seen identity matrix, right? A into I is always equal to I into A is always equal to A. So if you have something like this, see, if you have something like A plus B square, right? A plus B square. So you will write it like a normal multiplication. A plus B into A plus B. So it will be A square, in the order it is AB plus BA plus B square. Right? But instead of B, let's say we use I. If it is A plus I. A plus I or I plus A whole square. What is that? That will be A square. Now I into A or A into I, it will be same thing. So it will be 2AI, which is 2A again. And then I square. Now I square is I. Right? So we can generalize it for power n also. Right? I square, I cube, I power 4, everything is I itself. So we can generalize it for power n also. Like A plus I to the power n, or A plus I, or let's say I plus A. This I will give you a feeling of 1 here. A plus I or I plus A to the power n will be equal to, this will be first term NC0 into I, second term NC1 into A, then NC2 into A square, NC3 into A cube, NCn A power n. Remember this result. Because every time I power something will remain I itself, and if you multiply it with the other matrix, it will remain that matrix itself, I into A, like that. Okay. So then talking about transpose of a matrix. So if it is matrix A, when you take transpose of it, A dash or A, we write it like this also, A dash or A transpose. In that case, what happens? Rows and columns get interchanged. Here 1, 2, 3, 4 was in a row, now it is in column. So when you say A transpose, rows and columns they get interchanged. Rows will become column and this column will become row, right? So if A is of order m cross n, then A transpose will be of order n cross m. Also, transpose ka transpose will be matrix A again, obviously. If it is a constant, you can always take constant outside. If you have this transpose in addition or subtraction, it can be distributed directly. Like you can see A plus B transpose, A transpose, B transpose, A minus B transpose, A transpose minus B transpose. Similarly like this. But if you have them in product, the order will be reversed. You see here, AB transpose is B dash. Like if you have more than two, A into B into C transpose, now that will be equal to C transpose, B transpose, A transpose. Right? The order will be reversed and then you can bring transpose. Then with this transpose funda, based on transpose funda, we define two types of matrices. The first one known as symmetric matrix. So symmetric matrix if A transpose is equal to A. If A transpose is equal to it is symmetric, and if it is skew symmetric, then A transpose will be equal to minus A. Let me show you an example of skew and symmetric matrix. See, here we have a symmetric matrix. A very famous example of symmetric matrix. Obviously, it will be a square matrix. ABC. You might have seen this. HGF. HGF. Guys, have you seen this? What is this? This is the delta expression. This is the delta expression. You see, ABC. So if you take transpose A at G, you see this. Whatever elements are there in the first row, same in first column also. Second row is HBF, HBF. Then GFC, GFC. So for this, A transpose is equal to A. So this is symmetric matrix. And what about skew symmetric? In skew symmetric matrix, the A transpose is equal to minus A. So if A transpose is equal to minus A, then all the diagonal elements will become equal to 0, right? See, apart from diagonal elements, A, I, J, right? If I is not equal to J, we see A, I, J will be equal to A minus of J, I. So if it is the diagonal element, then it will be A, I equal to minus A, I. Sum will become equal to what? It will be equal to how much? All the elements in the diagonal will become equal to 0. I think I said opposite or what? In skew symmetric matrix, all the elements in diagonal will be equal to 0. 0, 0, 0. How it is clear? See, this is a 3 cross 3 matrix I am writing. 3 cross 3. You see? Aij. If you put J equal to I, so Aii will be equal to minus of Aii. So all the elements in the diagonal will be equal to 0. So like this is one matrix 0, 0, 0. Then this is the 2, 3, 4. So just minus of it. Minus 2. Then minus 3, minus 4. So this is skew symmetric. 0, 2, 3, 0, minus 2, minus 2. You see, the B transpose will be equal to minus of B. This is skew symmetric. Okay. Now this is the point here. In skew symmetric matrix, all diagonals is 0. A minus A dash. Now A plus A dash. Now how A plus A dash is symmetric, you see, or A minus A dash is skew symmetric. Let's say I'll show you this. So assume a matrix X, that is A minus A transpose, right? So what will be X transpose? It will be A minus A transpose transpose. We know that transpose is distributive over addition subtraction. So you can write it like A transpose minus A transpose whole transpose. By the property, we know that this is going to be equal to A, take minus common. This is A minus A transpose. Now A minus A transpose was X, so that is equal to minus X. So we have shown that this X transpose is equal to minus X. So A minus A transpose will be what type of matrix? Skew symmetric. Okay. So the next example, every square matrix. Now this is very, very important, guys. It has been there in exams also, that every square matrix can be uniquely expressed as sum of symmetric and skew-symmetric. Instead of that A being symmetric and symmetric, it does not matter. If you have a square matrix A, we can write it as a combination of skew-symmetric matrix and symmetric matrix. And we'll take help of A plus A transpose and A minus A transpose. You see, A plus A transpose is symmetric, A minus A transpose is symmetric. So, skew-symmetric. So, can I write any matrix A equal to 2A by 2? Now, this 2A, I'll write it like this. I'm just manipulating. So, this 2A, I'll write A plus A transpose and plus A minus A transpose by 2, right? Then you split it. So, A plus A transpose by 2, this is the one part, and this is the other part, A minus A transpose by 2. That is what we had to prove. That is what we have to show, that any square matrix A has been written as combination of, this is symmetric, this whole part is symmetric, and this is skew-symmetric, right? And this has been there in exams. You have to know, and it's quite easy, right? It's quite simple to observe it. Okay. Then let's solve few problems from previous year. Number of elements in the set A where I is 2 cross 2 identity matrix. Okay. A is such that I minus A cube, guys. I minus A cube is equal to I minus A cube. I minus A whole cube is equal to I minus A cube. So just expand it. Just expand it binomially. So first term will be I, right? Then second term will be 3C0, 3C1, 3A plus, and then it will be minus of I here, or plus of I. Last term will be what? 3C0, 3C2, 3C3, and minus A cube. Last term will be minus A cube is equal to I minus A cube. So this A cube, I will get cancelled. So we have, guys, 3A equal to 3A square. So basically we have A equal to A square. So this is the condition that we have derived. Now from here, there is one mistake that students do. From here, some of the students, they conclude that A equal to A square. So let's cancel this. So A is equal to I. No, this is completely wrong. Don't do this. Don't do this. There is no such cancellation thing in matrix, right? There is no cancellation thing in matrix. Here A minus A square, if you take A common. Now there is one more error. There is one more mistake I'll show you that student do here. Very, very common thing. What they'll write? Okay, so A square minus A is null. So take A common. So A minus I equal to null. So either A is null or A is I. Now this is also incorrect. This is also incorrect. Why? We just had done the property that if A into B is null, that does not mean A is null or B is null. Not at all. Right? So if you write it like this, it is completely wrong. Don't judge by this. There's a funda for it. We take determinants, and by determinant we'll decide something about A, that, like here, see. After this step, suppose here we don't have idea about A into D. We don't know what is determinant of A is equal to. In the same problem, suppose if we had idea, if we know, okay, if we had idea that A inverse exists. If A inverse exists, in that case, we'll multiply both the sides. A inverse A into A minus I is equal to A inverse into null. So then A minus I will be equal to null and A will become equal to I. But only in the case if A inverse exists. Do we have any idea about A inverse or A minus A inverse, A minus I inverse? No. Right? A minus I inverse also we don't have any idea. So you are not supposed to apply these things at all. So whatever you have to conclude, it has to be from A equal to A square. Right? I hope I made my point clear, guys. Many students, I've seen, like, not every year I've seen some few students doing this mistake. And if you are slightly weak at maths, then you will definitely do this mistake, because it feels like, okay, let's cancel it out. But there is no such thing in matrix. So A equal to A square, guys, what is A square? A square will be AB 0D multiplied by AB 0D. Right? So what is that? What is that? AB 0D. So it is A square, then this is 0, this is A square. Then this is AB and plus BD. AB plus BD. Then 0 into A, 0, D into 0, this is 0, and 0 into B, 0, D square, right? Now you equate it, it's just like finding elements, right? Now what we can equate, that A square equal to A, so AB 0D is equal to A square, AB plus BD 0 D square. Just equate them and now find out about the elements. So we have A equal to A square, D equal to D square. So from here either A is 0 or 1. Same with D. D is either 0 or 1. Then we have the other elements also. You see A, B, and this is A into B. So this B is equal to B times A plus D. So from here we can see, we could take B common, you will have A plus D minus 1 equal to 0. We'll have two cases, either B equal to 0 or A plus D equal to 1. So B is equal, if B is 0, if B is equal to 0, then we have total 4 cases about A and D, right? If B is 0, in that case, AD. This AD can be either 1, 0, 0, 1, 0, 0, 1, 1. There will be total 4 cases, right? And if A plus D is equal to 1, now that can be possible with 0, 1 or 1, 0. And what about B? B can be 1 or minus 1, right? B cannot be 0 here. So there will be 1, 0, 1, 1, 0, minus 1, total 4, 4. So 4 cases from here, 4 cases from here, total 8. So in total, there will be 8 cases for the given A square equal to A result. Clear? I hope it is clear. And almost every question of such type, guys, will have of this form, is A power 6. So there are types of question which you will see many, like numerous in numbers in JEE main exam. And what is that? The higher powers of matrix. And there is only one way. You calculate A square, A cube, right, and try to generate the pattern. That's all, right? Or what you can do, or you can write A with help of, identity matrix. Like here I can say that A is equal to, this is 1, 0, 0, right? 0, 1, 0, 0, 0, 1 plus, what is it, guys? 1, 0, 0, 0, 1, 0, 0, 0, 1 plus. So if I separated I here, what is remaining? This is 0, 0, 0, right? 0, 0, 1 and 1, 0, 0, like this, something like this, right? Or let's see, this is the second thing. This is the second approach when the direct product A square, A cube is not giving us any clue. So this is the first thing. Let's calculate directly what is A square, A cube, or all other things. So A is equal to 1, 0, 0, 0, 1, 1, 1, 0, 0. Let's find out A square. So it will be 1, 0, 0, 0, 1, 1, 1, 0, 0. How much is that? You see 1, 0, 0, so it will be 1. Then 1, 0, 0. So 1 into 0, 0, 0. So 1, 0, 0, 0, 1, 0. So 1 into 0, 0, 0 into 1, 0. It is again 0. Then second row. So 0, 1, 1, 1, 0, 1. So 0 into 1, 0, 0, 1. This is 1. Right? 0 into 1, 0 plus 1 into 0, 0, 1 into 1, 1. Then 0 into 0, 1 into 1. And then 1 into 0. So it's 1 again. Then 0 into 0, 1 into 1, 1 to 0. So it's 1 again. Right? 0, 1, 1, 0, 0, 1, 1, 1, 0. Fine. Then 1 into 1. And rest all will be. So this is 1. Then this is 1 into 0. This is 0. 0. So this is what we got as A square. That is what we got as A square. Now what is A cube, guys? This is A square. What is A cube? So A cube is 1, 0, 0, 1, 1, 1, 1, 0, 0. A square multiplied by A. 1, 0, 0, 0, 1, 1, 1, 0, 0. So if you find out this product, what is it? 1, 0, 0, right? This is 1, 0, 0 multiplied by 1. So 1 into 1, 0 into 0, 0, so this is 1. Then again it is what? then again it is this is 1 0 0. This 1 0 0 will be multiplied to 0 1 0. 1 into 0, 0 into 1, 0 into 0, so this is 0. 1 is 0, this is 0. Then 1 1 1. So 1 into 1, right? This is 1 into 1 and 1 into 0, so this is 2. 1 into 0, 1 into 1, this is 1. 1 into 0, 1. 1 into 1, 1, then 0 0. So I think now you should be able to find a pattern here. What is a power 4? What is a cube, right? So what is a power 4? A power 4, this will multiply. So I think this will be 1 0 0, 3 1 1 and 1 0 0. Got the point here? Got the point? Right? So a power 4, this is a cube, it is 2. It is a square, it is 1 here. So if I write a power n, obviously it should be n minus 1, right? So what is we have to find out? A power 2025 minus a power 2020. So what is that? So if it is 2025, guys, I can see this is 1 0 0, this is 2 0 2 4, and then 1 1, and then 1 0 0. This is a 2025 minus a 2020. So 1 0 0, this is 2 0 2020. So that will be 2 0 1 9, 1 1 1 0 0. If I subtract it, what am I getting? I'm getting 0 0 0. This is 5. This is 0 0. This is 0 0 0. Which I can write as, I can write this as with help of a power 6. So this will be 1 0 0, 6 1 1 1 0 0. This is a power 6 minus this a 1 0 0, then 0 1 1, and then 1 0 0. Do you get it? The same thing, right? So a 2025 minus a 2020 is equal to a power 6 minus a. And you see, this is the answer. Now what I want you to learn from here, see, this is the type of problems you will get in matrix. Most of the time from matrix it is about finding the relation between higher powers of a and a. Like here I could find out that I found out a square, I got nothing. Then I found out a cube, I saw the pattern. This 1, this is 2. Then I find out a power 4, this is 3, that's all. You need to calculate only square, power 3, power 4, and that's it, you have it. Okay, so I hope you have got it, guys. Okay, moving on. So n belongs to natural number, this is it, where, so I can say that this set here, this must be equal to identity matrix, right? So this set A, which is matrix 0, iota, 1, 0. This power n, this must be equal to identity matrix, correct? Only then in that case it is ABCD, the same thing. So how is it possible? How is it possible? So let's find out. Let's say this is A, right? This is A, right? And a power n becomes equal to I, right? A power n becomes equal to I. So let's find out what is a square. So a square is 0, iota, 1, 0, and 0, iota, 1, 0. So what is it? This is 0 into 0, this is iota. 0 into iota is 0. Then 1 to 0, 0 into 1, right? And then 1 into iota, this is iota. Something like this. This is a square. Now let's find out what is a power 4. So a power 4 will be iota 0, 1 iota multiplied by iota 0, 1 iota. So that is equal to how much? This is iota square minus, this will be minus 1, right? Iota square is minus 1, and then 0 into 1 is 0. Then iota into 0, iota into 0, 0 into iota, this is 0. Then 1 into iota, and this is iota into 1, this is 2 iota. And 1 into 0, iota square minus 1. Something like this. 1 to 0. So there is no such pattern till now that we have got. I hope my multiplication is correct, guys. 0 iota 1 0. So 0 iota 1 0. So 0 into 0 and iota into 1. Right? 0 into 0, iota into 1. Then 0 into iota, this is 0. 1 to 0. Okay. That is incorrect. That is incorrect. This product got incorrect here. Right. Let me change it. Okay. So this is 0 into iota, and this is 1 0 0 1. This is 0 and 1 into iota. Okay. So that's it. A square is nothing but iota into matrix I. Game is over. A square is equal to iota into A. So if this is iota into A, then we want this to be equal to I, the power n. We want A power n. We want A power n to be equal to I. So you can see that A square is in terms of iota, and iota power 4 is 1. Iota power 4 is 1. So what will be A power 8? A power 8 will be equal to A square to the power 4. What is A square? I into iota into I to the power 4. So that is equal to iota power 4, I power 4, which is I. Got it? So this is the multiple. This should be multiple of 8. So number of 2-digit numbers in the set, and it is up to where? Number 2-digit. I think there is no restriction given, guys. I think it was 2-digit. Okay, 2-digit. So 2-digit, it will be 16, then 8, 3, 24. It will be up to 96. Right? So there will be 11 elements. There will be total 11 elements. Why? Because that n will be multiple of what? N is multiple of 8. N is multiple of 8. So how many multiples of 8 are there in 2-digit system? 11. Clear? So nice question. Not difficult. So A is a real matrix of order 3 cross 3 such that you see AI1, AI2, AI3 is 1 for I equal to 1 to 3. Then the sum of all the entries of the matrix AQ is equal to. Now for that again you see AQ. What we have been given? A is a real matrix of order 3 cross 3. So A is equal to this is A11, A12, A13, this is A21, A22, A23, and A31, A32, A33. This is given. And it is being said that AI1. So A11, A12, A13 is 1, A21, A22, A23 is 1, A31. So sum of all the elements in the row is equal to 1. So to get to A cube, we have to see what happens with A square. We have to see what happens with A square. So what is A square, guys? So A square will be A11, right? Let's multiply. A11, A12, A13, A21, A22, A23, A31, A32, A33. Multiplied by same thing. A11, A12, A13, A21, A22, A23, A31, A32, A33. This is A square. I'm finding A square. First of all, what is the sum of all the elements in A? It is 3. Sum of all the elements in A is 3. We have to find the sum of all the elements in AQ. Now let's do it for A square. So in A square, you can see A11 will get multiplied to, like here we'll have A11 square, then A12 multiplied by A21, right? A12 multiplied by A21 and plus A13 multiplied by A31. Now what I want to show you, guys, that in the product, how many terms are going to be there? So many terms are given. Every time, like if we have A12 into A21, then do we have, like if we have A12 into A21 and A13, this is the first element, A13 into A31, like out of those 9 elements, this is the first element, right? What about the other one? Now it will be A11, A12, A13 with all these, right? So it will be A11, A12, right? It will be first row, second column. So A11, A12, then A12, A22, and A13, A32. There is no space to write the third one. Now I want you to focus on one thing here. When you will add all the elements, no, one thing you'll see. Let's see with A12. So if I take A12 common, then I'm going to have A21, then I'm going to have A22, and then I'm going to have A23 also there. You see A23 how? This is A12. So A12 is there. So this will be or A23 into A23 into we have A12, no. So A23 into this is A12, right? So A21, A22 and A23. How is it there? Can we have an element? A21. So A12 is being multiplied to A21, then A22, right? And then if you multiply with the third one, obviously it will be A23 also. So if you take A12 common, when you add them, so this sum will become equal to what? 1, and there will be only A12 left, right? Similarly, if you are seeing A11, so A11, then and you take it common, then you will have A11, A12, A13. That sum will be also 1. So again, out of that, only A11 will be left. So after all, when you add everything, same process is going to occur, and the sum of all the elements will remain 3. If you add everything, just like here, because what is happening every time you can take this term common, like you can take this term common every time you can take this thing common, right? So ultimately it will be sum of all the elements again. Like in the end, you will be adding these elements only, because this is what you have been taking common, right? How many elements are going to be here? How many elements? You see, this is the 9 in 1, so total 27. So here also it's like you will take 1 and then there will be 3 in common, right? You will take this 3. So 3, 3, 6, 3, 9, and you can see 9 into 3, 27. There will be total 27 terms. And every time if you add them, the sum is going to be 1, 1, 1. So ultimately you will be adding these elements only, and the sum will become equal to 3. So not just for a square, a cube, a power 4, for a power n, the sum is going to be equal to 3 only, right? Slightly difficult to visualize, but I can hope this 27 counting is going to have you, like it is going to like make you explain a bit of it what I just trying to explain you, because obviously it is not possible for me to write everything and show. You have to think. Just like here I've shown that if I take A12, I'm going to have A21, A22, A23 common with me, right? So same will be with other elements also. So when I'm adding everything, in the end, I'm going to add only these elements. So the sum will be equal to 3. Okay? Hoping that you have got it. Moving on. You can remember the result also, guys, for the previous problem. A is given the number of matrix with entries from the set 1, 2, 3, 4, 5 and satisfying AB equal to B. So quite easy. Let's say B is an element which is A1, A2, A3, B1, B2, B3 and C1, C2, C3. Okay, these are elements from matrix B. So what is A into B, guys? What is A into B? We have A into B is equal to B into A given, right? A into B given equal to B into A. So what will be A into B? So 0, 1, 0, A1, B1, C1. So what will be there? 0, 0, 1 into B1, right? 1 into B1. Then 0, 1, 0, this is B2. Then 0, 1, 0, this is A3, B3. Then second row. So 1, 0, 0 multiplied by A1, B1, C1. So 1 into A1. 1, 0, 0, A2, B2, C3. So it will be A2, A3. Then third 0, 0, 1. So it will be 0, 0, 1, A1, B1, C1. So only C1 will remain. 0, 0, 1. This is C2, C3. So this is the product A into B, right? Let's write the product B into A. So what will be B into A? So A1, A2, A3 multiplied by 0, 1, 0. So A1 into 0, 0. A2 into this will be A2, right? Then this will be A1, A2, A3, 1, 0, 0. So it will be A1, right? This A1, A2, A3 multiplied by 0, 1, 0. It is A2. Then A1, A2, A3, this is multiplied with this. It is, sorry, A1, A2, A3 multiplied by 1, 0, 0. It will be A1. Then A1, A2, A3 multiplied with 0, 0, 1, it will be A3. Like this. Then B1, B2, B3 multiplied with 0, 1, 0 will be B2. Then B1, B2, B3, this will be B1 and this is B3. Then again, we have C1, C2, C3. It is C1, C2, C3 and 0, 1, 0. So it is C2, C1, C3. Right, now start equating these numbers. AB is equal to given B. So B1 is equal to A2. Right, B2 is equal to A1. Then B3 is equal to A3. Fine. A1 equal to B2, that already we have written. A2 equal to B1 written. A3 equal to B3 written. Then C1 equal to C2. And C2 equal to C1. That's all. C3 equal to C3. So after knowing all these things, if I write fresh matrix B, how do I write? How do I write, guys? How do I write? A1, A2, A3. So if I write A1, A2, A3. A1, A2, A3. Now B1, B2, B3. So B1 is what? A2. B2 is what? A1. And B3 is A3. And then C1 equal to C2. So C1, C1, C3. So how many distinct elements we are using here? How many distinct elements? A1, A2, A3, C1, C2. Distinct elements are only A1, A2, A3, C1 and C2. That's all. Right? Only these 5 elements are being used and we are using them to write all the 9 elements. So what was that? Number of 3 cross 3 matrices with entries from the set 1, 2, 3, 4, 5 and satisfying. So for A1, A2, A3, C1, C2. So how many elements? Okay. So for each we'll have how many options? For each we have 5 options. So 5 for A1 we have 5 options. A2 we have 5 options. We have 5 options. 5 options, 5 options. So it is 5 to the power of 5. Okay guys, so let's solve next question now. So the total number of 3 cross 3 matrices A having entries from the set was that sum of all diagonal entries of AT. Now guys, this is one variety which has been very, very frequent in last 2 years. Because this type was first asked in advance. After that, this type got repeated in JEE Main. Right? So you just see this problem. You see there was at least 4 problems in last year paper which was exactly like this. In many shifts there were problems exactly like this. So just see the method. And every time the entries will be integers. That is one common thing in all the question you will see. First thing, they'll ask about sum of diagonal elements. Second thing, they'll say that those entries are integers. So let's see what is A. Let's say A is A1, B1, C1, A2, B2, C2, and A3, B3, C3. What will be A transpose? A transpose will be A1, A2, A3, sorry, A1, A2, A3, B1, B2, B3, C1, C2, C3. This is A transpose. So when you multiply A into A transpose, I am just going to write diagonal elements. What are diagonal elements? You see A1, B1, C1. So it will be, the first element will be A1 square, B1 square, C1 square. A1 square plus B1 square plus C1 square. What will be second element? Doesn't matter. Then this diagonal. So it will be A2, B2, C2, A2, B2, C2. So that will be A2 square plus B2 square plus C2 square. Similarly, the third diagonal element will be A3 square, B3 square, C3 square, right? So what is being said that the sum of these diagonal elements is equal to how much? It's 9. Okay guys, so A1 square plus A2 square plus A3 square plus B1 square plus B2 square plus B3 square plus C1 square, C2 square plus C3 square equal to 9. And what are the entries that we are allowed with 0, 1, 2, 3? So obviously 3 cannot be, 3 can be there. If we take 3, right? So that is possible. Rest all has to be 0. So let's start with the combinations of 4. Like we have a square here. So let's start with 3 square. So 3 square will be 9. So 3 square. So if one is 9, the other was are 0, right? So how many combinations will be there total? 9 combination. There will be total 9 combination for it, right? Any one can be 3 because 3 square will be 9. The rest all has to be equal to 0. Then if we have 1 4, right? If you have 1 4, so 1 4 and then 5 of them will be 1. So 1 2 3 4 5, right? 4 2 2 1. The rest all will be 0. So it's like that. This is distribution. This is like arrangement of the terms. So how many are there? This is 9 factorial divided by, we have 5, right? 5 identical 1 and 3 identical 0. So 9 factorial divided by 5 factorial, 3 factorial for the second combination. Now this time we had only 1 4. We can have 2 4s also. So let's say there are 2 4s. That is a1 square 4, then 4. So we'll have how many 1? We'll have only 1. So 0 0 0 0 0, right? 4 4 8 1 9, and then we have 6 0. So this combination will be equal to 9 factorial divided by, this is 6 factorial, 2 factorial, right? So this is the second one and third one. Anything else which is possible? Apart from this, anything else which is possible? Yes, it is possible. If we have all 1, if we have all 1 1 1 1 1 1 1 1 1, so that is only one such case possible, right? So either we have 1 3, rest all will be 0. If we have 1 4 2 4, and if you have all of them as 1, right? So in total you just add them, that these are the 4 combinations that you can have if you want sum of diagonal elements to be equal to 9. So in some other problems they will give some other cases, some other sum of diagonal elements. Method will remain same because the entries are going to be integers. So it's very easy to count what exactly will be the possible combinations. Okay, let's move to next question. Okay. Let A be a symmetric matrix of order 2 with integer entries. Sum of the diagonal elements of A square is 1 possible. So you see same question, integer entries, right? Possible number and sum of diagonal elements of A square. I'm leaving up to you. Same combination. You just see how many ways you can make that sum equal to 1. It's totally up to you. You can simplify it. ABCB all real, satisfying AQ, BQ, CQ is 2. Matrix A is gives this, satisfy A transpose equal to I. So guys, from here I can say that if I take determinant both the sides, it's basically a determinant problem. You can solve this with matrix concept also, but you see A transpose into A, just imagine the calculation. It's going to be very huge. So I'm going to take determinant both the sides. Now there's a property of determinant, right? We can split it like this. This is 1. So A transpose and is always equal to A. This is 1. So determinant A square is equal to 1. So determinant of A is either 1 or minus 1, right? 1 or minus 1. Now it's given that AQ, BQ, CQ is 2. We have to find value of ABC. So this is the type of standard determinant. This is a type of standard determinant. What its value? Its value is 3ABC. 3ABC minus AQ, BQ, CQ. That is equal to 1 or minus 1. This is this type of this is a standard determinant. You will see in today's class, this is type of standard determinant whose values will be either 1 or minus 1. Okay, right? This is a matrix given, but I am going to do with determinant method because it's easier. Now 3ABC. And what is this? This is, how much is this? AQ, BQ, CQ is how much? It is 2. So minus 2 is equal to 1 or minus 1, right? So what is it? So ABC will be equal to either 1 or this is plus 2, 1 upon 3. So either is going to be 1 or 1 by 3. So which one is there? 1 by 3 is there. That will be your answer. Right, from determinant method we have finished this problem within seconds. But if you go by that matrix logic, the product of matrices, it will be too huge. So just ignore that. Right, and in today's lecture I have included some important determinants whose value you have to remember at any cost. Okay, so it's not a big deal here that I wrote directly that this is the determinant value. We'll see today. Okay, so next question here. So P is a matrix given, Q be 2 3 cross 3 matrices such that Q minus P5 is equal to I3. So Q is equal to, okay, this is not P5 guys, this is p to the power 5. So q is basically p to the power 5 plus I. Then, okay. So what is this p, guys? This matrix p, if I write it as a sum of identity matrix, so this will be I plus what? I plus, this is be 0, 0, 0, then this will be 3, 0, 0, and this will be 9, 3, 0. Okay. So I've split P as I plus some this matrix. Right? This is what this is, lower triangle matrix here. So now let's say this is some matrix, this is some matrix B. So what is B square? Let's see what happens if we deal with higher powers of this matrix B. What is B square? B square is 0, 0, 0, 3, 0, 0, 9, 3, 0 multiplied by 0, 0, 0, 3, 0, 0, 9, 3, 0. Right? Now some of you will have this doubt that, sir, why exactly you have taken data matrix as I plus something? Because see, it's easier to multiply if we have more number of zeros. And here I can see by splitting this, I have more number of zeros, and identity matrix is already involved there. So there might be some relation. So that is why. So if I multiply, this will be 0, 0, 0. All the elements, right? Then second, 3 into 0, this is also 0. This is also 0. This is also 0. And then 9 into 0, 3 into 3, this is 9. And what is next? 9 to 0, 3 into 3, 9, this is 0. That is fine. So 9 to 0, 3 into 0, this is 0. 9 to 0, 3 into 0, 0. You see how nice this matrix B square has come up. Now what is B cube? What is B cube? So B cube will be 0, B square into B, 0, 0, 9, 0, 0. This being multiplied by matrix B, which is 0, 0, 0, 3, 0, 0, 9, 3, 0. So I think you can visualize now that this product 0, then 0, this is 0 again, then 9, 0, 0, this is 0, 9 to 0, this is 0. We have got this to be null matrix. So if B cube is null, then B power 5 will be what? It will be also null. Right? B power 4, B power 5, B power 6, everything is going to be null. So it's written that some matrix Q is P power 5 plus I. Right? What is a matrix P? B 2, 3 cross 3 matrices is that. B 2, 3 cross 3 matrices is that. Q is equal to P power 5 plus I3. So guys, I think now you can see what is P power 5. P power 5 will be I plus B power 5. Right? So it will be the first term will be equal to 5C0 is I, then second term 5C1 into B, then 5C2 into B square. Rest all need not to be written because it is 0, because B cube is null. So if B cube is null, rest all terms will be also null. So we don't need to write them, it is 0. So what is it? P power 5 will be equal to I plus 5C1 into B. So 5B and plus 5C2 is how much? 10. And what is this B square? Do we have any relation with B square and B? We don't have any relation. So 5B plus 10B square. Right? So this P power 5 plus I. Right? So P power 5 plus I will be equal to, so if I add one I more, so P power 5 plus I will be equal to 2I. So what is this 2I plus 5B? So now I think you have everything, no? You have 2I, you have 5B, right? And you have 10B square, this B square. Everything is there with you. So you can find out the overall calculation, and then you can find out these elements Q. Because what is Q? Q is this matrix. Q is P power 5 plus I, right? So P power 5 plus I we have got in very simple expressions. 2I is this. Now you have to add 3 matrices. So if you want me to add, let me do it for you. 2, 0, 0, 0, 2, 0, 0, 0, 2. 5B. What is 5B? 0, 0, 0, 15, 0, 0, 0, 5 into 9, 45, 15, 0. And plus 10B square. 0, 0, 0, 0, 0, 0. Then 10 to 9, 90. right? So now if I find out final addition, so 2 0 0, so 0 15 is 15, 2 0 0 45 90, so it is 135, 0 15 2. That's it. This is the final matrix Q. This is matrix Q. This is matrix Q, right? And what do you want? You want Q21. So Q21, what is that? So this expression now we'll calculate. So second row, first element, Q21, it is 50. Third row, first element, it is 135. Divide by third element, second is 15. So it is 150 by 15. What is that? 10, and that is your answer. Clear? So this was the trick here, writing P. See, even if you directly calculated P square, P cube, P power 4, you would have got the pattern. But you see, if you write P as something B plus I, if we have written P as I plus B, now that has made calculation far more easier, right? So these all are some simple tricks which you will only know if you have solved more and more questions. Now let's go with the determinants. You see, determinants will only talk about properties of determinants. The basic definition, you know what is a determinant, right? Every matrix comes with a scalar value, every square matrix, right? So the first property here, this is mod of A, determinant of A equal to A transpose. This, if the value of determinant is altered, if the rows and columns are interchanged, okay, then if any two rows are interchanged, it will have a negative sign then, right? If you are doing odd number of changes, there will be a negative sign, okay. Then if you multiply by any lambda, it will get multiplied to any row or column, not like matrix. In matrix, if you multiply, it gets multiplied to whole row or column. But here in determinant, if you multiply by constant lambda, it is going to be multiplied to any row or column, right? Then there is a property, if you have det of AB, you can write det of A, det of B. Then if there is any constant lambda, right? This is very important case. This property is very, very important. So if lambda is a constant, A is the matrix of nth order, so lambda will be equal to lambda power n A. And why this happens? Because see, if you write lambda A, so it's like all the elements will be multiplied by lambda, 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 lambda. So you can take lambda out from all the rows or all the columns. So it will be lambda power that order. So it will be lambda power n. Skew-symmetric matrix of order has a determinant value 0. Why it is so? Why it is so? Skew-symmetric matrix has always its determinant value 0, odd order of odd order. Why it is so? Because you see, A transpose is equal to minus A. So if I take determinant both the side, determinant of A transpose equal to determinant of minus A. So determinant of A transpose will be A. This will be minus 1 to the power n into determinant of A, right? And since it is odd degree, so this will be det of A will become equal to det of minus A, and thus determinant value will become equal to 0. So standard fact, odd order skew symmetric determinant will have determinant value. Skew symmetric matrix will have det value 0. Then determinant has all the elements in 0 in any row or column, it will be 0 because we'll expand through that. Determinant has any two rows identical. If we have any two rows identical, it will be equal to 0. Very basic properties most of you are already aware of. Okay. Then if each element of any row can be expressed sum of two terms, then we can split it. Why? Because this is just like simple expansion. It is A1 plus X multiplied by this. So first A1 will be multiplied, then plus X will be multiplied. What is it? First A1 will be multiplied, then X will be multiplied. So it's just like adding two determinants, right? But remember that while using this property, you can do, you can split it only one row at a time. Like if we had something this, if you have A1 plus X and A2 plus X1, B2 plus Y1, C2 plus Z1, then this will split into four different determinants. Got my point, right? You can split only one row or one column at a time. If we have multiple rows or column written with this plus X plus Y expression, you cannot do with all the rest simultaneously. One row or one column at a time. Then this is a property which is used for transformation. That in any determinant, if you add, subtract any multiple of the other row, or if you do the same thing with column, the determinant value will not be going to change. Like what happens, like here you can see row 1, here what is the transformation that has been used? Row 1 has transformed, like row 1 has been transformed as row 1 plus m times row 2. Then row 3 also has been transformed as row 3 plus m times of row 2, n times, right? So these two transformations have been done, right? Now this is also equal to D1 itself. Why it's so? Why it is so? Because you can split it as two different determinants. You can write D2 as, I'll write MA2, MB2, MC2, A2, B2, C2, or will be as it is, right? Plus, it will be A1, B1, C1, A2, B2, C2, or as it is. Plus, then again I'll split. It'll be A1 plus, right? A1, B1, C1, A2, B2, C2, and then it will be A3, B3, C3, A3, B3, C3, plus this A1, B1, C1, A2, B2, C2, and then NA1, NA2, NB1, and C1, right? So what happens with this? MA2, MB2, MC2, you take out this M common, and then you have A2, B2, C2, A2, B2, C2, two identical row, this becomes 0. What about the second one? Now this is A1, B1, C1, A2, B2, C2, and this is A3 plus NA1, right? A3 plus NA1, B3 plus NB1, and C3 plus this. So now this has been written as, this we'll write as A1, B1, C1. So this I have written as A1, B1, C1, A2, B2, C2, and then this will split into A3, B3, C3, and then again NA1, NA2, and C. So what happens then? So when you have written this, as sum of these two, so you can see the other one also has NA1, NB1, C1. So you take N out, so these two will become identical. So this also will be 0. Only this will be left out, which is determinant D1, right? That is why the transformation of addition, subtraction is not going to make any difference. Make sure one thing, that whatever row or column is going transformation, the coefficient is 1, right? If the coefficient is not 1, you will change the value of determinant, right? So you have to keep that in mind, okay? So this is a transformation property which you will see again and again. Then this property is very useful, the product. Then this is also there. Then if you have something like determinant of a to the power n, this will be determinant of a whole to the power n. That can be also remember as a property. Now why is it so? Because this a power n, no? This is a power n. So you can write a into a into a into n times. So it becomes det of a to the power n. Remember it. Then the sum of the products of elements of any row. Now this is very, very important, guys. You see, suppose we have a determinant A1, A2, A11, A12, A13, A21, A22, or let me show it with 2 by 2 cross 2, right? So there, I don't have much space to write. A11, A12, A21, A22. So for any matrix, we define minors and cofactors, right? Suppose minors for this minor matrix, for this cofactor matrix of A, right? So cofactor of A will be what? Cofactor of, let's say it is for A11 it is C11, it is C12, C21, C22. This cofactor. I hope you know what is minor cofactors. When you calculate minor, you just for any particular element, right? So you remove that row and column. Whatever determinant is left will be its minor. Like for A11, if I have to find minor for A11, right? Remove that. What is left? A22. If it was 3 cross 3 matrix, we would have a determinant left. But here this is 2 cross 2, that is why only one element is left. So minor of A11 will be A22. And what is cofactor? Cofactor is minor of that element multiplied by minus 1 to the power the location of that element, the ith row plus jth column. So it will be minus 1 to the power 1 plus 1 into minor of that element. Getting a point? Cofactor is equal to cofactor, like cofactor of any element aij is equal to minus 1 to the power I plus j into minor of that element aij. Minor of that element aij. This is it. Right? So minor, how to get minor? You understood that? Remove that row column, whatever is left, that is minor, and then multiplied by its what? Cofactor. Multiplied by its sign minus 1 to the power I plus j. So then similarly you can see, like if you have to find the cofactor for a22 or let's say a21. So remove that row column, a12 is left out. So a12 is minor for a21 and cofactor will be minus 1 to the power 2 plus 1, that is minus of a12. Now let's talk about the property. I hope that all of you are aware of this minor cofactor. Now let's talk about the property, guys. The property says that if you multiply elements, right, with their corresponding cofactor and you add them, then you get the determinant value, right? If you do with other row column cofactor, it will come out as 0. Let me show it to you. So what did it say? That determinant of A will be equal to A11, C11, C. First row element, first row cofactor. So A11, C11 plus A12, C12. This will be det of A. Or if you want to go for second row, so second row element with second row cofactor, corresponding cofactor. So this is A21, C21 plus A22, C22. Now this is row wise. We can do such thing with column wise also. Determinant can be expanded from row column everywhere. So if you go column wise like this, so A11, C11 plus A21, C21, or then second row, second column. So it is A12, C12 plus A22, C22. So I hope you are able to observe the pattern. It is the row or column, then we are considering the same cofactor set, right? So that will give you determinant value. Like you see, if I write actual cofactor here, what is cofactor matrix of A? Like guys, if I write cofactor of A here, what is that? What is cofactor of A11? Sign will be plus, it is A22, right? What is cofactor for A12? Sign will be negative, minus A21. What is cofactor of A21? Sign is negative, minus A12. What is cofactor of A22? It is plus A1. Right? Now just replace it. So what is cofactor 11? It is A11, A22, A12 minus A21. That is the determinant, guys. What is determinant of A? That is A11, A22 minus A12, A21. That is the determinant value. You see, you calculate with any of these four expressions. Let's calculate with this. A12, C12. So A12, right? A12 is A12. What is cofactor 12? What is cofactor 12? It is minus A21. Right? Plus A22. A22 is A22. And what is cofactor 22? Cofactor 22 is A11. You see, exactly same thing. Exactly same thing. A11, A22 minus this. Getting a point? So the property says that any row or column multiplied and then added with the corresponding cofactor will give you determinant value. But if you do otherwise, if you take row one element multiplied by cofactor of other row. You take elements from row 1 and cofactors from other row, it will be 0. You see, A11, C21. What is value of A11, C21 plus A12, C22, guys? So what is A11 into what is C21? What is C21? Cofactor 21 is minus A12. Plus what is A12? A12 is A12. And what is cofactor 22? It is A11. You see, what is that? It's 0. A11, A12 minus A11 which is 0. So this is the property. If you take column 1 element and you take cofactors of column 2, it will become 0. But don't take row column. Only row column is there. We cannot say about row column operation. Same logic applies for 3 cross 3 also. So I hope you can relate there, guys. Okay. Now what is determinant of cofactor matrix? You see, determinant of cofactor matrix, what will be that? That is also one result which you should definitely know. The result of, suppose there is a matrix A. Okay. A11, A12, A21, A22. Right. So, or let's write 3 cross 3. You will understand better. So A is element, A11, A21, sorry, A12, A13, A21, A22, A23, A31, A32, A33. This is matrix A, and I am writing cofactor matrix of A. So it will be C11, C12, C13, C21, C22, C23, C31, C32, C33. Right? Okay. Now guys, if I what I do, okay, so if I multiply, okay, if I multiply them, then what will happen? If I multiply CA, what is going to happen? If I multiply A into this cofactor of A transpose with their transpose, right? A with cofactor matrix of A transpose, what is going to be happening then? You see, if A into cofactor of transpose, so A11, A12, A13, it will be C11. What is CA transpose? CA transpose matrix will be C11, C12, C13, C21, C22, C23, C31, C32, C33. So we have multiplied them. So C11, C12, C13. So A11, A12, A13, C11, C12, C13. What will be that? That will be delta A, determinant of A. Right? Then again, if I multiply A11, A12, A13, C21. Right? So that will be C21. So that is second row element will be 0, 0. It will be 0, determinant of A into 0. Then 0, 0 determinant of something like this. So which is equal to what? Determinant of A into I. So if I take determinant both the sides, now if I write determinant of A into determinant of cofactor of A transpose, determinant of cofactor of A transpose, what is that equal to? Determinant of I. Now we are dealing with a 3 cross 3 matrix, so it will be equal to what? Det of A into, we know that the matrix determinant, the value of determinant, or if you take the transpose, it is same. Determinant of A is equal to determinant of A transpose. So I can write determinant of cofactor matrix of A is equal to, now this is determinant of K will be equal to what? K power n, this is 3 cross 3. So it will be out with power 3 into, that's all, I 1. So you can see guys, determinant of cofactor matrix we are getting A square. Now if it is 3 cross 3, so if from here I'll generalize one result, if A is n cross n, then cofactor matrix of A will have determinant of A to the power n minus 1. This is what I wanted to show you. The relation between matrix and its cofactor matrix determinant. Cofactor matrix of A determinant will be det of A to the power 1, just like here we have shown it, it is A square. Okay. Moving on. Now the frequently asked determinant, frequently used determinants value, you see for A, B, this is skew-symmetric, you see. This is odd order skew-symmetric, it is 0. In all these things, just you have to memorize. You have to memorize the exact value. You see here ABC, this we have used negative of ABC, so you can write it otherwise also. This will be equal to ABC, 3ABC minus A cube, B cube, C cube. Same thing. right? Then 1a is 1a square, 1b b square, 1c c square is a minus b b. This also, this is very very frequently asked in JEE main. Like in between, so like you will have a expression, while solving that in between you will get something like this. Okay, so 1a square, it will be a minus b, b minus c minus a. Remember for a cube also, a b c will remain same, then a plus b plus will be extra, and here this term will be extra. Remember all these 5 determinants. You are going to have them directly in your exams. Okay, remember the values because it is going to be there in calculation. Multiplication determinant. Now here you can multiply row by column. Obviously it has to be of same order, right? Here strictly they have to be of same order square matrix. So it has to be row by row, row by column, or it can be row by row. This is also allowed, or it could be column by row. This is also allowed, or it could be column by column. Anything is allowed, right? Mostly we prefer row row or row column. Suppose determinant of a, det of a is something a b c d, and b is something l m and p. So if I have to multiply a into b, right? If I have to multiply determinant of a and determinant of b, so it could be row wise, row or row. It could be row by row multiplication. It will be al plus bm, row 1 row 1, then row 1 row 2 here, an plus bp, then cl plus dm, and then cn plus dp. So this is row by row. You've seen row row multiplication. You can do column column also. AC ln first, then AC MP second, like that, right? So I prefer, in general, I prefer row row multiplication or row column. AB ln, right? This is equal to what? If you go row by column, so it is AL plus BN, or in second column AM plus BP, or CL plus DN, or CM plus DP, like that, right? This is row row and this is row column. So in general I prefer these two because it's easy to visualize. Because see, in JEE main, you see the problems from multiplication matrices are very rare. In JEE advanced they are very frequent. In JEE advanced the problem will be opposite. They will give you product and then you have to identify matrices. It becomes very difficult. Okay, so for now you just have to remember only these things. Clear? Row row or row column, anything is fine. So then starting with the problems, guys, starting with the PYQs. Okay, so we are going to use the simple transformation properties, or the simple properties where we can multiply, divide inside. You know what, all this 11, 12 properties we did in the beginning, that is what we are going to use. Okay, so let's start out. Okay, so let's solve some determinant problems, some PYQs based on the properties of determinants. The first one here you see the determinant, then set of values of x. So see, here first of all, what property we should use? You have box of x everywhere. So there is a simple property that box of x plus integer is equal to box of x and plus integer, right? If you have integer there, you can separate it out. So I can write this thing as a equal to determinant of, let's say determinant of a we are finding out. So this determinant of a will be equal to this box of x, and let's say for example we are taking box of x as t, because difficult to write again and again. Assume that box of x is t. This will be t plus 1, and this is t plus 2, this is t plus 3, right? This is t plus 3, t plus 3, this is t plus 2, t plus 4. That's it. That's it, right? It's very simple form. Now what to do? You just need to subtract this, the transformation this will do. Row 2 will be transformed as row 2 minus row 1, and row 3 will be transformed as row 3 minus row 1. That's all. So it is t plus 1, t plus 2, t plus 3. So t minus t is 0. This is 1. This is minus 1. Right? We are subtracting row 3, row 2 minus row 1, then row 3 also minus row 1. So it is minus 1. I think this is plus 1, no? row 2 minus row 1. Okay. Okay, wait a minute, guys. The transformation that I've written here is that row 2 is being transformed as row 2 subtracted from row 1. So t plus 1 minus 1, t plus 3, t plus 2, 1 is 0. Then row 3 also minus row 1. So this is minus 1, t plus 2, 0, 4, 3, 1. So if you calculate it, now you can easily find out that what exactly will be the answer. Because determinant of A now is just expansion. You will have something in terms of x. What is it? This is expanded. So t plus 1 into this is 1 minus t plus 2 into what is it? This is minus 1. And then this is t plus 3 into this t plus 2 into minus 1, t plus 1 into 1, and t plus 3 into this is 0, t plus 3 into this is 0 plus 1. So t plus 3. So guys, this is the t 3t 1 2 3 3t plus 6, which is equal to 192. So 3 box of x plus 6 is equal to 192. 3 into box of x is equal to this is 186. So box of x is equal to how much? This is 3 6, it is 62. So box of x is 62. That means x will belong to n plus 1, 62 to 63. This will be open interval. That is the answer. That's all. Clear? Quite easy. This is what? Once you write it like this, you know how to transform, and very easily it got transformed. Nothing difficult at all. Moving to next one. Fx is this maximum value of fx. So you can see, if you have to maximize it, what should we do? If you look at the determinant here, what we should do, so that we give, see, the idea always that, the idea of transformation is always that we should make more number of zeros. The more number of zeros we make, it's easier to expand, right? So here, what is the thing that it looks easy? I think the first thing that looks easy is that transform R1 as R1 minus R2, and then transform R2 as R2 minus R3. Do these two. So R1 minus R2. It is minus 2. Then it is minus 2 plus cos square x. Cos square x, it is minus 2 again. And this is 0. What about the second one? This is 2 plus sine square. So I am transforming R2 also, R2 minus R3. So it is 2, it is 0, then minus 1. Then sine square x, cos square x, 1 plus cos 2x. Now there is nothing difficult to expand here. Just expand it easily, right? Or to make it slightly more easier, you can do this transformation. Transform column 1 as column 1 plus column 2. What will happen? Minus 2 minus 2, minus 4, or do one thing. Transform column as column 1 minus column 2, right? So this will be 0, minus 2, 0. This will remain same. Sin square x minus cos square x will become minus cos 2x. And this is cos square x, and this is 1 plus cos 2x. Right? Now we can expand through first row. When you expand through first row, what is det of A now? If we expand this determinant through first row, this is the minus plus 2, because the rest all are 0. So plus 2 into 2 plus 2 cos 2x, 2 plus 2 cos 2x, right? And minus plus, again 1 minus. So guys, this is it. The game is over. 2 plus cos 2x. And what we have to do? Maximize. So if you want to maximize this function, obviously cos 2x has to be equal to 1. For maximum, this is twice of 2 plus 1. This is 6. 6 is the answer. Quite simple. Like matrices problem are like slightly challenging, but determinants, this is going to be always this easy. Was few transformation of addition, subtraction, you will have your answer always. A, B, C, D be an arithmetic progression. Okay. So if A, B, C, D is an arithmetic progression, let's say that B is something, A plus D, C will be equal to what? C will be equal to A plus 2D, and we can replace D with A plus 3D, right? Right. So if you do that, you see, if we do that, this is right, this is equal to. If we replace B with A minus C. So what is A minus C, guys? A minus C will be what? A minus C will be A minus C. So A minus C will be minus 2D. So X minus 2D. X plus B. X plus A plus D. X plus A. Then X minus 1. X plus C. C is X plus A plus 2D. And X plus B. Right? This is X plus A. So X plus B will be X plus A plus D. Then X minus B minus D. So guys, B minus D is the minus 2D. So it will be X plus 2D. X plus 2D. X plus A plus 3D. And X plus C. A plus 2D. This is given 2. Right? So now everything is in terms of A and D. So it's easy to simplify here because we can do this simplification from here. If I subtract like row column 2. If I subtract column 2 minus column 3. If I do this transformation, column 2 is subtracted. Right? Column 2 is subtracted from column 2 minus column 3. If I do this transformation, so it is X minus 2D. So X plus A plus D minus X plus A. So what is it remaining? It's only D. And this is X plus A. Right? Then X minus 1, X plus A plus 2D. X plus A plus D. So if I subtract it, it will be only D remaining. This is X minus 1. This is X plus A plus 2D, X plus A plus D. So X plus A, only D will remain. And this is X plus A plus D. Then again X plus A plus 3D. So it is only D. X plus 2D. This is D. And this is X plus A plus 2D. Right? Few more steps we can do. This is 2. Right? Now I can write it as sum of two different determinants. I can write this as sum of two different determinants. If you are not understanding, basically this will be now X minus 2D, X minus 1, X plus 2D, D, and then X plus A, X plus A, X plus A, plus, right? X plus A, X plus A, X plus A, plus. What is next? Basically this is X plus A plus 0, right? So I can write it X minus 2D, X minus 1, X plus 2D. This is D, and what is left here? 0D, 2D, 0D, 2D equal to. So this will be 0. Why? Because you can take D and X plus out, so you will have both rows with 1, 1, 1 as the element, right? I can take D common from here, so only 1, 1, 1 will remain. I can take X plus A common from here, so 1, 1, 1 will remain. Subtract it, 0. So now this is easy to calculate. I can take D common from here, right? So it will be D square. And determinant, now this is X minus 2D, 1, 0. X minus 1, this is 1, 1, and this is X plus 2D into 1, 2 equal to 2. So now you can simplify very easily. You know, you can expand it through any row column. You can do one more time subtraction. Like just subtract these two and your game will be done. Easy, very, very simple problem. Is see this C here, right? The only thing that we had to slightly solve was this part, right? And again, it's not, this is a type of transformation which will strike to everyone. Even if you have solved NCERT, guys, see, in this crash course, I'm assuming that you have at least solved NCERT. And if you have solved NCERT determinants, then these type of transformations are nothing. It's a easy game for you. Moving on with the next question. Almost similar expression we had dealt with. Solution of the equation from x 0 to pi. So 1 plus sine square, 1 plus sine square. So guys, you can see the first thing that strikes is that let's transform R1 as R1 plus R2. Right? What will happen? If I do that, you see, if I transform R1 as R1 plus R2, it will be 1 plus sine square plus cos square x will be 2. Sine square plus cos square x plus 1, 2. Sine square cos square x, 2. And then we have cos square x. We have 1 plus cos square x. We have cos square x again. And then we have 4 sine 2x 4 sine 2x, 1 plus 4 sine 2x equal to 0. So once we have similar elements in the column, see what is the goal of transformation? To expand. Before we expand, we want that determinant to be in the easiest possible form. So we have scope of making 0. To subtract, right? We'll do the transformation, column 1 minus column 2, and column 2 will be transformed as column 2 minus column 3. First this will be done, and after this transformation will be done. So 2 minus 2 0, right? This will be minus 1, this is 0, and again 2 minus 2 0, this is 1, minus 1, and then we have this 2 cos square x, 1 plus 4 sine 2x. So now we'll expand through first row, right? So it will be, this will be what? This will be gone. So what will remain then? What will remain? If I expand it, so it is equal to, okay, so there is no sine term will remain. What is this? Is everything correct? 1 plus sine square x plus cos square x, it is 1 plus 1 2, sine square x plus cos square x, it is 1 again 2, and okay, sorry, this is 1 here. This is 1. My bad. This is 1 here, guys. Right, this is 1. Now this is 2. This is 1. Right? Yep. So 2 minus 2 0. Okay. So this is 2 minus 2 0. 2 minus 1 1. This is 1. So now the expansion will work. So this is minus 1 times 1 plus 4 sine 2x. Right? 1 plus 4 sine 2x with a negative sign, and this is 0. So minus minus, this will become plus, and plus 1 into this is minus minus plus 1. This becomes 2 plus 4 sine 2x, and that we are putting it equal to 0, right? So 2 plus 4 sine 2x is 0. So sine 2x is equal to how much? It's equal to minus half. Sine 2x is equal to minus half. So we want solution between 0 to pi. So this 2x must be between what? This 2x will be equal to sine theta is minus half. So in the second quadrant, if you look at the angles for theta, right? In the third and fourth quadrant, so what will be 2x? 2x will be 1 by 2. This is pi by 6. So pi plus pi by 6, 7 pi by 6, and 11 pi by 6. So x will be equal to 7 pi by 12, 11 pi by 12. That is your answer. Clear? There was one mistake here. It was 2 and 1. So that got corrected, and we have our answer. You see the calculation, guys. Is it tough? Does it look tough from anywhere? The transformations are so easy here. It's only like add and subtract, and it's always obvious. It's always obvious in the problems. Moving on to next question. Hello. Yeah. So here question is, let A be a 3 cross 3 matrix with determinant of A equal to 4. Determinant of A is 4. Let R1 denote the ith row of a matrix B is obtained by performing the operation, right? Of matrix B with the operation R2 transformed as, right? R2 being transformed, okay. R2 is being transformed to R2 plus 5R3 on 2A, right? So 2A. So 2A will be basically what? 2A. So when matrix is 2A, basically all the elements are being multiplied now. 2A11, 2A12, 2A13, 2A2n, 2A22, 2A23. All the elements will be multiplied. 2A31, 2A32, 2A33. Right? All the elements will be multiplied by 2. Now, so on this 2A, what we are doing? This R2 is being transformed as, 2R2, right? So we are multiplying here. What is this B? In this matrix B, we are multiplying. R2 is being transformed as 2R2 plus 5R3. 2R2, right? We are multiplying this by 2. So if we are multiplying this by 2, right? We are multiplying second row by 2, and then we are adding 5 times R3, right? So this 5R3 will not have any effect, but this 2R2 will have some effect, and this 2R2 You see this 2 R2 here. So if I take determinant value, it will be 2 to 2 cube 8 out, right? And we are transforming R2 as 2 R2 plus 2 R 5 R3, right? If I am talking about determinant, so I'll multiply 2 again with the root 2. So 8 into 2, right? Rest all will not change because the plus this transformation will not change. If the coefficient is the factor which gets changed because 2 R2 is there. So that 2 will take it out. So 16 times. And what is det of A? It's 4. This is given 4. So it is 16 into 4 will be equal to 64. Right? Quite easy. First of all, matrix was made 2A. So when we take determinant, so 3 cross 3, so it will be 2 cube 8. Now there will be 2 also out. Why? Because R2 is now 2 R2. Plus 5 R3 will not have any effect. That we already have seen the property of determinants. Okay. We do any transformation with addition, subtraction of any other row column. Nothing is going to change. If the coefficient is not 1, that is what makes the difference. This because of this 2 R2, that 2 will be right. Because once we have taken 8 out, it's like A11, A12, A13. I hope you are getting it, guys. I hope you are getting it. See what has just happened. Let me explain what just happened. So when we take determinant here, right, what is determinant of B? What is determinant of B? In this 2A, we are doing this transformation that makes it B. So determinant of B. So when I take this 2 out, it becomes 8, right? And this is 2A. This is A11, A12, A13, A21, A22, A23. Now R2 has been transformed as 2 R2, right? 2 R2. So 2 R2, so it is 2 A21 plus 5 times R3, A31, right? This is 2 A22 plus 5 A32, 2 A23 plus 5 A33, then A31, A32, A33, right? So basically A12, A13, we should write it properly. Now this is A11, this is A12, A13, A32, A33. Right? So this is B, right? So if you find out its value, right? We know the value of det of A. Now what is A, guys? A is simply A11, A12, A13, right? So this 5A31 will not have any effect because again we'll transform. We'll write R2 as R2 minus 5 times R3. Only this 2A21, 2A22, 2A23 will remain, right? And then this 2 can be taken out, right? Understanding what happens? Like I'll retransform R2 as R2 minus 5 times R3. So then what will happen? You will have A11, A12, A13, 2A21, 2A22, 2A23, and the same. Then 2 will be taken out. So this is a determinant. So this will be det of B will be equal to 8 into 2, 16 into. Remember, you will have only det of A left out. So it is 16 to 4. Value will be 64. So now I suppose this should be clear. This is very easy problem, not a challenging one at all. So A is given, guys. This type of determinant you already have seen. I have in that part where I have shown you 5 determinants whose value you have to remember. This is one of them. And what is its value? Det of A is equal to minus of A plus B plus C into A square B square C square minus AB minus BC minus AC, right? It's given that A square is I, right? It's given that A square is I. So determinant of A square will be equal to determinant of I. So determinant of A will be equal to 1 or minus 1. Now is it 1 or minus 1? We can see it's given that x plus y plus z is positive. So this is positive, right? And this is always positive because this expression you must have seen. What is this? This is perfect square. This is sum of half of A minus B square, B minus C square, C minus A square. This is sum of squares. So this is always positive. So this is given positive, right? Okay, this is AB, not ABC, X, Y, Z. Okay. So I hope you can understand, right? A is X, B is Y, C is Z. So det of A should be equal to what? Plus or minus? This is negative. Rest two are positive. So det of A will be, this will be something negative, right? So from here we can see that det of A will be equal to -1. Now, now. Let's write its value then. So if det of A is negative, so can I say this is equal to 3ABC? 3ABC or XYZ, it's not ABC, it's XYZ. So 3, I'm writing its value. So 3XYZ minus AQ plus BQ plus CQ. This is determinant value. This is det of A. This is equal to what? -1. Correct? This is equal to -1. Now what is XYZ? It is 2. It is 2. So this is 6. 6 plus 1, 7 will be value of AQ plus BQ plus CQ. This will be the answer. Right? This XY, okay, again I've written A. This is X, guys, sorry. This is XYZ, this is XYZ. I'm again writing ABC. So XQ plus YQ plus ZQ will be equal to 3 into 2, 6, 6 plus 1, 7. 7 is the answer. And you see, this question ideally in exam, it should take less than 30 seconds. Right? If you have the idea about expansion, like what is the determinant expansion, right? Here A is X, guys, okay, don't confuse. A is X, B is Y, C is Z, X, Y, Z, X, Y, Z, like that. Right? And this is standard determinant whose value we have already remembered. And plus or -1, that is also being decided easily. Okay. So let's solve next question now. So let A be a 2 cross 2 real matrices with entries 0 and 1. And this is also given. The determinant of A is non-zero. Right? Determinant of A is non-zero. So then either it will be 1 or -1. So if determinant of A is 1, then what type of matrices are possible? Let's see. Either it is 1 0 0 1 or 1 0 1 1 or 1 1 0 1, right? For these cases, det of A will be 1. We can make det of A -1 also, like 0 1 1 0 or 0 0 1 1 1, or if it is 1 0 1 1, right? In these cases, det of will be -1. Now what is being said? If A is not I, then det of A equal to -1. You see, if A is not I. Okay, so even if A is not equal to I, we have det of A equal to 1 also. Correct? Even if you can see, we have -1 and 1 both possible. Even if it is not equal to I, this is not I. In these two cases, A is not I, but still det of A is equal to 1. So this is a wrong statement. If det of A is 1, then trace of A is 2. Right? 2, 2, 2. So this is a correct statement. So P is false and Q is true. Clear? Quite easy. See, total, there will be many other cases, but initially they had said that det of A is non-zero. So with entries 0 and 1, only these two cases were possible. I have just written those matrices, and now it's become very obvious to answer which option is correct. Easy. And similar easy problems were there, guys, in exam every time. B plus C. So you have to basically find out coefficient of x square, coefficient of x. You can directly expand with some transformation. Like suppose in this question, if it was about only D, that find D, what is value of D? So it would be very easy problem. What exactly we had to do? We had to just put x equal to 0. You will put x equal to 0, you will get value of D. Both sides, put x equal to 0. In general, this is the problem which gets asked in competition. You put x equal to 0, then the constant part you will get it. Okay? But here they want B and C, so we have to expand, but expand it with some transformation. So transform rho 1 as rho 1 plus rho 2. Transform rho 1 as rho 1 plus rho 2 and then minus rho 3. Do this transformation. So this delta will be equal to rho 1 plus rho 2 will be 3x minus 5. 3x minus 5, this becomes 0. Then 2, 3, 5x minus 7. 5x minus 8, it will be 1. 7x minus 12. So minus 3x. So minus 3x, 7x, 3 plus 4, 7x minus 3x. 4, 5, 7. Right. 4, 5, 9, sorry. 3, 4, 5, 9 will be plus 8. Rest all will be as it is. 2x minus 3. 3x minus 4. 4x minus 5, 3x minus 5, 5x minus 8, 10x minus 17. So now it's just expansion. So you expand it, you will have a cubic expression, right? This is 1 into, you can see you will have a cubic expression. This will be something like px cube plus qx square plus rx plus s. Then you find it, you find this q will be equal to b and c will be equal to 1. Just expand now. After this step, you just expand through first row. You can see now it has become easier. And even after this step, if you want to make it slightly more easy, then you can do, you can subtract with columns also, guys. But I'll not suggest that. You just expand it and you will have your answer here. So the minimum and the maximum values of the function of this. Now again, but just by looking at the terms, you could see easily that we are supposed to what? We are supposed to add them. So the first transform will be, you transform row 1 as row 1 plus row 2. And what you will get? What is that you will get? Minus sin square minus cos square theta minus 1. Minus 2 minus 2 minus 3. 1 plus 1, 2. Right? Then minus cos square theta. Minus 1 minus cos square theta. And 1, 12, 10 minus 2. So you see, now it has become easier. This determinant has become easier now. Initially it was sin square, and it was obvious if he has sin square, cos square, we'll add them up. What else to do? Now further calculation, before we do that, we have scope of simplifying it further. What we can do in that, if I subtract column 1 minus column 2, right? Column 1 minus column 2, it will be 2. It will be 2. Then this will be only plus 1. Because minus cos square theta minus plus 1, this will be gone. 12 minus 10, 2. I have transformed here column 1 as column 1 minus column 2. So should we do column 2? Yeah. Then do this. Transform column 2 as column 2 plus column 3. Do that. So minus 3 plus 2, minus 1, this is 2. This, if you add it, it will be 0. So it will be only minus cos square theta. 1, 10 minus 2, 8, minus 2. Now see how easy has this become. There is only one cos square term here, so how easy is this to expand? So what will be this f theta? So this f theta now you can write twice of. So this is 2 cos square theta minus 8, right? 2 cos square theta minus 8, minus minus plus 1. This is minus 2, and minus, this is minus 2 minus 4, and plus 2 times, this is 8 and plus 2 cos square theta. What will be the final expression, guys? This is 2 to 4 cos square theta. So this is 4 cos square theta to 4, 4, 8. 8 cos square theta, right? 4 cos square theta and 4 cos square theta. Then 16 minus 4 plus 12 and minus 4. Right? 16 minus 4 plus 12 and 12 minus 16 minus 4. So if I take 4 common, this is 2 cos square theta minus 1, which is nothing but 4 into cos 2 theta. You see, this is it, how simple this expression has come out to be. 4 into cos 2 theta. Now what do we want? Between pi by 4 to pi by 2, right? So 2 theta will be what? Theta is between pi by 4 to pi by 2. So 2 theta will be between pi by 2 to pi, right? So between pi by 2 to pi, cos will be what? From minus 1 to 0. Minus 1 to 0. So there is a 4 multiplied outside. That's it. This is the range, guys. That's it. You see, similar questions, almost every problem, the transformation is always easy to visualize. In J advanced question, you will have some difficulty, but here it's obvious. A equal to Aij, B equal to Bij, B2 matrices such that Bij equal to Aij. Okay, so what is Bij? So if matrix A is A11, A12, A13, A21, A22, A23, A31, A32, A33, right? So what is matrix B? So it is I plus J minus 2. So what will be the first element? I1, J1, 0, 3 power 0, so it is only A11. Second element, this is 2 plus 1, 3, 1. So 3A, 1, 2. Then this will be 1 plus 3, 4. So 3 square. 3 square, A, 1, 3. right? What will be 2, 1? So 2 plus 1, 3, 3 minus 2, 1, 3, 8, 2, 1. Then next element 2, 3, 5, right? 8, 2, 2, 2, 4 minus 2. So 3 square, A 2, 2, 3 cube, A 2, 3. Then it will be 3 square, A 3, 1, 3 cube, A 3, 2, and 3 power 4, A 3, 3. So this is how B looks like. Now we have, see, if it is determinant here, then this is determinant of B, right? This is determinant of B. So if this is determinant of B, so what we should do? What I can take common here? If this is determinant of B, I can take 3 common, right? I can take 3 common, like 1, 3, 3 square, right? So I can take 3 common from here, or what else? Yeah, I can take 3 square common from here. I can take 3 square common from here. I can take 3 common from here, right? And then, so once I take 3 square common from here, 3 common from here I'll take 3 square common, and from here I'll take 3 common. It will give me 3 cube, right? I've taken 3 square common from here and 3 common from here. On this column, I'm talking about the column part, guys. I'm talking about the column. So it will be A11, 3A21, 3 square A31. And again here it is 3A12. So 3 has been taken common. It is 3A22 and 3 square A32. So I hope you can see that what will be our next step. It is 3 A23, 3 square A33, right? So I have taken common 3 and 3 square. Now from row you can take common. So from this row you can take 3 common, and from this row you can take 3 square common. So 3 cube into 3 square again, that is A11, A12, A13, A21 and so on. So that is basically how much? 3 cube. So 3 cube, 3 power 6. So 3 power 6 into determinant of A, right? So what is that? Determinant of B is 81, right? So 81 is equal to 3 power 6 times determinant of A. It is 1 by 3 square. That's it. And you see, this is 2020, 2020. These are 2020 problems, 2021 problems, and these are this simple. There's nothing else to worry about this chapter. Okay, so let the numbers 2, B, C be in AP and A. So guys, you can see this is a standard determinant, and we have written this value. See, 1, it's A. Let's let this 2 be, for instance, A. So this is like 1A square. 1B, B square, 1C, C square. So we know the value. It is A minus B, B minus C, C minus C, right? If it is 1A square, 1B, B square, 1C, C square, this is the value. So A is what? A is basically 2. So 2 minus B, B minus C, and C minus 2. So 2B and C are in AP. Okay. So what will be 2 minus B or B minus C? So this 2, B is 2 plus D, C is 2 plus 2D, right? What is 2 minus B? 2 minus B. B is 2 plus D. It is minus D. What is B minus C, guys? B minus C will be 2 plus, this is again minus D. And what is C minus? What is C minus A? So 2 plus 2D minus 2, it is 2D. That is 2D cube, and that is given 2 to 16. So this 2 times D cube is given from 2 to 16. So D cube is between 1 to 8. So definitely D is from 1 to 2. Common difference D will be from 1 to 2. So what is that we have to find out? Then C lies in the interval. So C lies in the, C is what? 2 plus 2D. So C is 2 plus 2D. So 2 plus, what is this interval 2D? 2 to 4 will be from 4 to 6. Guys, so simple. The only thing which could have could make this question complicated is if you don't know how to write the direct value. And I told you initially that these are the determinants which gets asked directly. For some of you, if you don't know the value, you will simplify it and then you will find value. If you remember it, you see, it will save you at least a minute At least a minute I'm saying. And otherwise the rest calculation were so simple. Next question. Okay, so here we have determinant A equal to this minimum value of det of A upon B. B is positive. So I think it's easy to write value here. We can expand det of A easily, but there is not much to do. Okay, let's transform us a bit. So let's transform R1 as R1 minus R3. It will be A will be equal to, this will be 1 0 minus 1 B square plus 1 B 1 B2. Now I think we can expand, or if you want to subtract one more time, let's add column 1 and column 1 plus column 3. So A will be equal to 1 minus 1 0 0 minus 1. This is 2B B square plus 1 B 3 B 2. So we have made two zeros. Now we can expand it. So minus 1 times it is 2B square. 2B square minus 3B square minus 3. So what is that? 2B square minus B square. So it is B square plus 3. So we have to minimize. What is minimum value of det of A by B? So det of A by B will be equal to B plus 3 by B. As given that B is positive. So if B is positive, you can use AMGM. We can use AMGM. So if you use AMGM, B plus 3B by 2 is greater than B into 3 by B under root. This cancels out. So B plus 3 by B is greater than 2 root 3. That's all. That is the answer. The minimum value will be equal to 2 root 3. Every step you write will give you an idea what is going to be the next step. Nothing is difficult. Nothing is difficult. I have just shown you from so many problems. So now we'll come to the next segment of the chapter, which is adjoint and inverse. What is adjoint? We have seen how to find out cofactors. So adjoint of any matrix A is equal to transpose of, right? It is transpose of cofactor matrix of A, right? That is adjoint of A. So if suppose A is A11, A12, A13, A21, A22, A23, A31, A32, A33. This is some given matrix A, and you already know how to calculate its cofactor matrix. So suppose cofactor matrix of A is C11, C12, C13, C21, C22, C23, C33, C31, C32, C33. So what is adjoint of A? Adjoint of A will be equal to transpose of the cofactor, and that will be C11, C12, C13, C21, C22, C23, C31, C32, C33. Okay, so this is a transpose. This is adjoint of A, right? One property you can see from here, that A into adjoint of A, guys. A into adjoint of A is always equal to det of A into IN. You can see from here. You see, if you multiply A into adjoint A, so what will be A into adjoint of A? You see, A11, A12, A13, C11, C12, C13. Next element will be A11, A12, 13. Second row cofactor. So when you are multiplying, see, when you are multiplying this A into adjoint of A, this A into adjoint of A, what is this taking form? A into adjoint of A, this is what it looks like. Suppose if it is 3 cross 3, right? Or let's say n cross n. So for example, if we have taken 3 cross 3, so it will be det of A 0, det of A 0, det of A. Right? So what is that? That is det of A into I. So A into adjoint of will be det of A into I. And many derivations are there which are being done from this result. So this is extremely important. Mark it very, very important. Where IN is identity matrix of nth degree. You okay? So let's see. So with help of adjoint, the result here that we have just got, that A into adjoint of A is equal to determinant of A into I. So from here we can write one property. Like in this, if I take determinant both the sides, so what is determinant of A into adjoint of A? Right? Well, let's say A is a n cross n. A is n cross n square matrix. So if I take determinant both the sides, so determinant of A into adjoint O is equal to determinant of into In, right? So by the property here, we can write this as a separate product. Det of A, det of adjoint is equal to, here we have the property, guys, that if there is any constant, determinant of K is equal to K power n into determinant of A by the property of determinants, where K is a scalar, A is of n cross n. So here I can write that this will be det of A to the power n into determinant of I will be equal to 1. So can you see that we have got this property that determinant of adjoint A will be equal to determinant of A to the power n minus 1. So this is one property which we are going to use a lot, really a lot, right? Remember the property, determinant of adjoint A is det of A to the power n minus 1. Why this happens? I just showed you. Okay, moving to the inverse part. So if there is a matrix B, if there is a matrix B, if there is a matrix A and B exist such that, if A and B are such that A into B is equal to, identity matrix is equal to B into A, then A and B are said to be inverse of each other. A and B are said to be inverse of each other. A is either B inverse or B inverse is equal to A. So now you have this result, right? You have this result that A into adjoint of A is equal to I, right? Det of I, let me write it. So A into adjoint of we had written, this is equal to det of I into In, and this is equal to adjoint of A into A also, same thing. This result we already have derived, right? So if I divide by det of A throughout, so A into adjoint of A divided by determinant of A is equal to I is equal to adjoint of A divided by determinant of A into A. Now can you see guys, what is this B? This A into B equal to I equal to B into A. That B right here is the inverse. So what is A inverse? This A inverse is equal to adjoint of A divided by determinant of A, and what is it, that one result we have to remember, provided this is non-zero. So this is very important. It's very important to know that inverse, if a matrix is invertible only in the case if determinant is non-zero. If it is a non-singular matrix, only in that case it will be invertible. So there are some simple properties that you should know. Sufficient condition is that A is non-singular, right? If det of A is non-zero, inverse will exist. Then A inverse is always non-singular. Obviously, if inverse is existent, it will be non-singular. A equal to, if you have a diagonal matrix, then A inverse will be, you can directly write reciprocal of them. Let's say for example, if A is A 0 0, 0 B 0, 0 0 C, right? And provided that this is a det of A is non-zero. So A inverse. So A inverse will be equal to 1 by A 0 0, 0 1 by B 0, 0 0 1 by C. This will be A inverse. Directly you can write inverse for diagonal matrix. Then transpose inverse we can interchange. A inverse transpose will be A transpose inverse, right? And A inverse also adjoint of A transpose will be adjoint of A whole transpose. This is also you should know. Adjoint of A transpose is equal to adjoint of A transpose. A inverse will be equal to A, fine. Then K of A inverse 1 by K inverse. Determinant of A inverse will be 1 upon determinant of A. Then A be a non-singular matrix. Now this is important, guys. This result. A and B be non-singular matrix, right? A is a non-singular matrix, and it's given that AB equal to AC. Only in that case B will be equal to C, because what just happened? If AB is equal to ABC, and since we know that A is what? A is invertible. I told you that this case I will discuss. See, AB equal to AC will result into B equal to C. Why? Because now we know it's given that A is invertible. So both side I'll multiply with A. So A inverse A into B is equal to A inverse A into C. So A inverse A is equal to I. So B equal to C will be there, right? So this is important to know. This is important to know. This product, this inverse का product that we take, this is important. Okay. AB inverse, B inverse, AB is equal to 0. So this already we have seen. Okay. Now properties of adjoint. Now every single property is super important, and I want you to remember all of these. Right? I've shown you. I've proven one or two for you. I won't prove everything, but I want you to remember all of these. You see, all of these properties, and all of these are being used again and again. You see, especially this property. JEE main is asking questions based on this property 3, property 2, property 1, property 7, everywhere. And see, the proving part is not that difficult. You can prove almost everything on your own, right? But you just remember, especially property 1, adjoint of A, we just had seen. If it is adjoint of A, it is det of A to the power n minus 2 into A. If it is, now let me show you how this happens. How adjoint of adjoint A becomes det of A to the power n minus 2 into A. How? See, you have seen, no? You have seen that A into adjoint of A, right? A into adjoint of A is det of A into I, right? This you had seen, det of A into I. Now I am replacing A with adjoint A. I am replacing A with adjoint A. Replace A. So adjoint A into adjoint of adjoint A is equal to determinant of adjoint A into I. Got the part? I have replaced all of A with adjoint A. Now adjoint A is what? Adjoint A. Now you know that. What is A inverse? You know that A inverse is adjoint of A by det of A. So I can replace adjoint of A with det of A. Right? I can replace adjoint of A with A inverse into det of A into adjoint of adjoint A is equal to, what is determinant of adjoint A? That we had already proved, determinant A to the power n minus 1 into I, right? So we have A inverse here, and this is A power n minus 1. So I'll divide it there. So A inverse into adjoint of adjoint A will be equal to det of A to the power n minus 2 into I. Now I'll multiply both the sides by what? I'll multiply both the sides by matrix A. So this A into A inverse will become what? I. A into A inverse will become I. So we'll have only adjoint of adjoint A this side, and this side A into. So we have, this is constant. So keep it aside. Det of A into A power n minus 2 into matrix A. And that is what we have here. So all these properties we can prove on your own. So especially property number 4, property number 5, 2, 3, 5, I won't remember, right? If it is adjoint of adjoint A determinant, it became square. If it is done n times, it will be power of n there, right? This is also very, very frequent. Adjoint of K, I'm telling you guys, property 5. Adjoint of K is equal to K power n minus 1 adjoint A. Do you want to see proof? Let me show you. What is adjoint of K? So adjoint of Ka is equal to what? So we know that B inverse is equal to adjoint of B divided by determinant of B, right? B inverse is adjoint of B divided by determinant of B. So I can say that adjoint of K, right? So let's replace B with K, where K is some constant. So Ka inverse will be equal to adjoint of Ka divided by determinant of K. Correct? So I can write adjoint of K is equal to Ka inverse into determinant of Ka equal to. Now K is a constant, K is a scalar value, so it will be K inverse. K inverse will be 1 by K. Let me write it properly. So this thing will be equal to 1 by K into A inverse into, now determinant of K, this is also property. So this will be K to the power n into determinant of A. Right? K will be K to the power n determinant of A. Now guys, this is what? K to the power n minus 1 into A inverse multiplied by determinant of A. What is that? A inverse multiply determinant. What is it? Adjoint. So k to the power n minus 1 into adjoint of A. And that is what we have the result. K to the power n minus 1 adjoint of A. And this property you are going to see a lot, right? This is not written, but let me write you let me write again, right? What will be determinant of A inverse? Determinant of A inverse will be equal to 1 upon determinant of A. That also you have to use again and again. So all these 8 properties, if you have time, you can prove, or else just memorize, mug it up, and let's solve some questions. Okay. The first question here, now it looks very lengthy. There is so much thing written here. Read it. A is given, B is given, Q is given, A transpose Bi. Then the inverse of the matrix Q power 21. So you see that some A, Q, whenever matrix has higher power, obviously there has to be some pattern, or there has to be something. So Q power 21. Now what is Q square? What is Q square? This is Q, right? Q square will be A transpose BA into A transpose BA. That will be equal to A transpose B into A transpose into BA, right? So there has to be, if there is any pattern, there has to be something with A into A transpose, right? It automatically it is giving us idea. So if you calculate A into A transpose, what is that? A into A transpose. So A is 1 by root 5. So let's take 1 by root 5 out. So it is 1, 2, minus 2, 1, right? Then A transpose, again take 1 by root 5 out. It will be 1, 2, minus 2, 1. It is 1 by 5 into, what is it? 1 to 1, 2. So 1 into 1, 2 into 2, 4. This is 5. Minus 2, plus 2, 0. Minus 2, right? Plus 2, 0. 4 plus 1, 5. That's it. What is that? That is the game, guys. This is the game. This is I. So we have shown that A into A transpose is equal to I. So this Q square is equal to A transpose into B. This is I. So B into B will become B square. Now you have seen the pattern. What will be Q cube? A transpose B cube into A. So what is A power Q power 21? So Q power 2021 will be equal to A transpose B power 2021 into A, right? So if you put this value here, what is it? A into Q power 2021 into A transpose is equal to what? A into A transpose into B power Q power 2021, B power 2021 into A transpose. So this is I, this is I. It is only equal to B to the power 2021, and B matrix is given. So this B power 2021 will also show some pattern. So what is B? 1 0 iota 1. So B is 1 0 iota 1, right? B is 1 0 iota 1. So what is B square? Let's see what is the pattern being showed. So this is 1 0, right? Obviously there has to be some pattern. So this is 1 0 iota 1, 1 0 iota 1. What is B square? 1 0, 1 into 1, 0. So this is 1. 1 into 0, this is 0. Iota into 1, this iota, this is 2 iota, right? Iota into 0, and this is 1. Clear? So what will be B cube? So it is 1, 3 iota, 0, 1, like that. So what will be B power 2021? It is equal to 1, 2021 iota 0, 1. And we want inverse of this, right? Question says find the inverse of it. So determinant value will be equal to what? 1. We can find out adjoint easily because there is only 2 cross 2, and this will be your answer. This B will be your answer. Quite easy, right? And see, every step you write is giving you idea that what is supposed to be done in next step. So don't get worried at all by looking at the length of the problem. Because this is determinant, it will look lengthy, some problems, but it will be super simple. Now see, A be a 3 cross 3 real matrix, we have to find out determinant of twice of adjoint of twice of. Okay. Okay, this 2 adjoint, I think this is separated, guys. So determinant of this is 2 adjoint, no, this is fine. 2 adjoint of twice of adjoint of. Twice of adjoint, then twice of again adjoint of 2 adjoint. Again adjoint of 2a. Right. So let's start from inside. Adjoint of 2a. So this is, now this is 3 cross 3. So this 2 we can keep it out, 2q into adjoint of 2. Adjoint of. Now this adjoint of 2a, guys. This adjoint of 2a, we can, adjoint of k is what? Adjoint of k is k to the power n minus 1. So k to the power n minus 1, what is that? 3 to the power 2 into adjoint of a. Right? Adjoint of a. Fine. Then this is 8 into adjoint of 2. Now adjoint of this is 4 into adjoint a. So again same process. Adjoint of 4 into adjoint a. So adjoint of 4 into adjoint a will be equal to 4 to the power n minus 1 into adjoint of adjoint a. One more. So 4 square 16, 32. So 8 into this 4 square 32. So 32 to the power n minus 1. which is what? N minus 1, n is 3. So 32 to the power 2 into adjoint of adjoint a. Right? So this 32 square is being multiplied to 3 cross 3 system. So 8 into 32 square power 3 will be out into determinant of adjoint a. 3 times. So by the formula we know this is equal to 2q into 32 is 2 power 5. So 5 into 2, 10, 30, 2 power 30. And this is determinant of a to the power n minus 1. N minus 1, this is 3, right? If we had adjoint of adjoint a, there is to be 2. So 3, this will be q, where n is 3. So this is 2 power 33 into det of a to the power. N is how much? N is 3 minus 2, 2 cube 8. And determinant of a is given? No, it's not. It's given 2 power 48. So this 2 power 33 into determinant of a to the power 8 is equal to 2 power 41. So clearly det of a is equal to 2. Right? 2 power 33, this is 2 power 8. So det of a is 2. So we have to find out determinant of a square. So it will be equal to a square. So 8 determinant of a is 2. So 2 square it is 4. Right? Determinant of a power n is det of a to the power n. Answer will be 4. So you see this. If you have idea about all the formulas, only then you can get it right. So the slide where I have shown you properties of determinant, adjoint, inverse, it's extremely important. Question here, a equal to this 2 higher than 4 alpha. So is this very simple, guys? You just calculate it. I'm not going to solve it. Find a inverse and equate it. This is the easiest possible problem that you can have from determinants. You just equate. You can find a inverse. No, what is adjoint? What is determinant of a? What is it? This is 4 plus 2, 6. Right? 4 minus 4 into minus 1 is plus 2, 6. What is cofactor of a? What is cofactor of a? So for 1 it is 4. For 2 it is minus 1, but there is a negative sign, so it will become plus 1. For minus 1 it is 2, negative sign, minus 2. For 4 it is 1. Right? Then transpose. So adjoint of a will be equal to how much? 4, 1 minus 2, 1. Right? 4, 1 minus 2, 1. This is adjoint of a. So a inverse will be 1 upon a. 1 upon 6 times 4 minus 2, 1, 1. Right? Now this you will equate to a alpha I. So this here is equal to alpha I. So alpha I is equal to how much? Alpha 0, 0, alpha. Alpha I plus beta times A. So beta times A will be what? Beta, 2 beta minus beta, 4 beta. Right? So now you can equate. From here you can see. So this will be 4 by 6 minus 2 by 6, 1 by 6, 1 by 6. This is equal to alpha plus beta. This is 2 beta minus beta and alpha plus 4 beta. And that's all. You just equated two matrices. You can find out. You see 2 beta is minus 2 by 6. So beta is 1 upon 6. You can see. From here we have beta is equal to minus 1 by 6. What is alpha? Alpha plus beta is 4 by 6. Beta is minus 1 by 6. Alpha will become 5 by 6. So 4 times alpha minus beta. So alpha minus beta will be how much? This is 1, 4. So answer will be 4. And that is the answer. Clear? So these type of questions are, I don't know why they even ask this kind of question. The direct comparison. Now this question, guys, is one of the finest problem that you will see from determinants, right? Because this involves the more of the concept. See the question. A and B with two 3 cross 3 matrices such that A square minus B square is invertible matrix. Okay. A square minus B square is invertible matrix. So determinant of A square minus B square is non-zero. A power 4 is equal to B power 5. A power 4 is equal to B power 5. And A cube B square is equal to A square B cube. This is given. Then the value of the determinant of the matrix A cube plus B cube is equal to A cube plus B cube. So A cube plus B cube, can I write it this equal to A square minus B square times, right? I can write this as or if I multiply these two. If I multiply these two, A cube plus B cube into A square minus B square, what all I am going to have? What all I am going to have? This is A cube. This is A cube plus A square, A power 5, right? Minus A cube B square, right? Plus B cube A square minus B power 5, right? So I think there is some error here. This is A power 5, guys. This should be A power 5. Right, there is a correction. This is A power 5. A power 5 is equal to B power 5. This should be given A power 5. Right. So now you can see this is given A cube B square and B A square B cube. Right. A and B A cube B square is in the value of determinant. Okay. Okay. So one more thing, this there it should be given that the product here is commutative. So what exactly is going to happen, guys? This whole thing becomes 0. So basically we have A cube plus B cube into A square minus B square equal to null matrix. Right? Now we know that A square minus B square is what? Invertible matrix. So I can take A square minus B square inverse both the sides. So I am going to multiply by A square minus B square inverse. So this is A cube plus B cube into A square minus B square multiplied by A square minus B equal to null. So this will be I. So A cube plus B cube is nothing but a null matrix. And if you take determinant, it will be 0. Right? So there are some misinformation in this problem. First of all, A power 5 was equal to B power 5. And this has to be commutative because only then A cube B square or B square A cube will be equal and the result will be 0. Right? A power 5 B power 5 will be 0 and this here will be 0. So then after that what I did? I took determinant here. I know that. See, directly from here you cannot comment, or from here also you could comment. You just take determinant both the sides. You will see that this is A square minus B square is invertible, so non-zero. So obviously it becomes 0. Now here one more information we have extracted, that A cube plus B cube is a null matrix itself. Not just determinant, the matrix itself is a null. You okay? So, okay, so let's solve next question. So A is given, determinant A power 4. So see here we have to deal with higher powers of A. So definitely there has to be some relation of A with these higher powers. So determinant of A power 4 a power 10 and this. Okay. So what is a square? A square is 2, 3, 0 minus 1, 2, 3, 0 minus 1. What is that? So 2 into 2, 4. Then this is 2 into 3, 2 into 3, 6. And 6 minus 3, this is 3 itself. Right? And then this is 0 into 0, this is 0, 0, this is 1. 4, 3, 0, 1, right? 0 into 3, 0, minus 1 is plus 1. What is a cube? So a cube will be 4, 3, 0, 1 multiplied by a. It is 2, 3, 0 minus 1. What is that? 4 into 2, 8. And then this is 4 into 3, 12. 12 minus 3, 9. And this is, what is it? This is a cube, bro. This is a cube. 4. A square is 2, 3. So 2 to 4, 0. 2, 3, 6. 6 minus 3, 3, 3. 0, 3. 0 into this, 0 into 3, 0. Yep. We multiply 4 into 2. This 4 into 3, 12. Minus 3, 9. 0. This is 0. Then 0 into 1. 0. This is minus 1. Right? A cube is this. What is a power 4? A power 4 will be 4301 multiplied by 4301. Now that is equal to 4 into 4, 16. And this is 4 into 3, 12. 12 plus 3, 15. And this is 0. And this is 1. Right. So can you relate that a square, a power 4? You see, so basically a power n is nothing but 2 power n. 2 power n minus of minus 1 to the power n, then 0 and minus 1 to the power n. I think now you can relate. You see, what is a square? A square is equal to 4. So when the power is odd, it is 2 cube plus 1. Power is even, 2 power 4 minus 1. Correct? So this is what a power n looks like. And now I think you can substitute it here and you can get all the answers. Okay. And you can find out about a power adjoint of a also. You can get the relation of the powers. Like this adjoint of 2a, you'll write it 2 to the power n minus 1. What is that? 2 minus 1. This is 2 cross 2. So 2 power 2 minus 1 into adjoint of a. And this is raised to the power 10. So you can find out adjoint of a. And you can get the pattern. What is the pattern being shown by adjoint of a, guys? So adjoint of a, like from here, I think you can find out, right? Just try it on your own. You can find out the pattern shown by adjoint of a, right? Adjoint of a, like so. There's a the transpose, the cofactor matrix. What is transpose here? For 2 it is minus 1. For cofactor matrix, for 3 it is 0, but there is a negative sign, doesn't matter. For 0 it is 3, the negative sign, and for minus 1 it is 2. So the transpose of it, so this is adjoint, minus 1, 0, minus 3, 2. Minus 1, minus 3, minus 3, 2, right? This is adjoint of a. So let's find out what is adjoint of a square. Do we have any pattern here? So minus 1, minus 3, 0, 2. Minus 1, minus 3, 0, 2. Okay. So what is it? You see, this is 1. Minus 1 to minus 1, 1. This will become 0. This is 3. And minus, this is minus 1 to minus 3 is 3. Minus 5. Right? And this is 0. And this is 4. So I think there is some pattern, right? There is some pattern. Now we have this minus 1 to minus 1 plus 1. This is plus 1, right? I don't know why I wrote 0. 1, this is 1 here. Right? So I think same thing you can find out. This is minus 3, this is minus 5, 2 square minus 1. 2 is 2 plus 1, 2 square plus 1 like that. So you can find this is 2, 2 power n like that. So you can derive relation between adjoint of a to the power n, and then you can take the determinant value. So this will be slightly lengthy, but again, the main part of this problem was understanding the pattern shown by matrix. Clear? Let's move forward. Okay, this is quite easy. Let A and B be two invertible matrices order 3 cross 3. Determinant of A be A transpose. So we can split A transpose is 8. So basically A transpose and A, these two are equal always. So we can write determinant of A square into det of B is equal to 8. Determinant of AB inverse is equal to how much? 8. AB inverse is equal to 8. So we can write determinant of A into determinant of B inverse is 8. B inverse is what? 1 upon B. 1 upon det of B is 8. So that's all. Use these two. You will multiply. So determinant of A cube is how much? 64. So from here we get det of A is equal to 4. And from here det of B will be how much? This is 4. So 4 by 8, 1 by 2. Right? Det of A is 4 and B will be equal to 1 upon 2. So we got det of A, det of B. Then we want determinant of B inverse B transpose. So that will be determinant of B square into 1 upon determinant of A. So B square will be equal to 1 upon 4. 1 upon 4. 1 by 16 will be the answer. This is the answer. So these kind of questions you are like there are chances that you are going to face these kind of questions. And if it is there, this is jackpot. There is nothing more to solve in this question. Moving to characteristic equation, which is not that asked in JEE Main, and in fact, like I've not seen any problem in JEE Main where they have asked a characteristic questions. What is it? So every matrix A, okay, every matrix A satisfies. Now this is square matrix, obviously. Every square matrix satisfies characteristic polynomial. Now what is it? You see, I'll explain with 2 cross 2. Suppose A is a matrix A, B, C, D. Right. So determinant of A minus lambda is equal to 0. Every matrix A, for every matrix A, we can generate this type of system polynomial. Now A minus lambda I, what is that? So it will be equal to determinant of A minus lambda I. So A minus lambda, B, C, D minus lambda equal to 0. So when you simplify it, what is it? This is A minus lambda into D minus lambda minus BC equal to 0. So this is lambda square minus A plus D into lambda minus this is plus how much? AD minus BC equal to 0. Right. So this is the characteristic polynomial. This is called characteristic polynomial. And this lambda here, now if I write this, now this is satisfied by A. This is satisfied by the matrix A whose characteristic polynomial has been derived. So this is A. A will satisfy this. What do we mean by that A is satisfied this? So if you replace A here, so A square minus A plus D into matrix A plus AD minus BC into matrix I equal to 0. This is characteristic polynomial of A. And here you can see this is A square minus, what is A plus D? Guys, A plus D is trace of A. A plus D is trace of A plus what is AD minus BC? It is determinant. So determinant of A into I equal to 0. So this is the characteristic equation you can say for a matrix A. So this I have shown you for 2 cross 2. What exactly you have to remember from here? We can use this characteristic polynomial for finding inverse. Right? When A inverse is written in terms of A square, right? Sorry, A, like if it is a 3 by 3, like from here I can find out A inverse. From this equation I can find out in A inverse. How? You see, this is A square. This is A square minus trace of A into trace of A into what? I forgot to multiply A. Into A plus determinant of A into I equal to 0. If I multiply this whole equation by A inverse, so A inverse into A square will be A minus A inverse into trace of A and plus this is A inverse into, okay, there is A also. So this A inverse A will become I and A inverse into det of I equal to 0. So clearly guys, A inverse is equal to how much? This is A minus trace of A into I divided by determinant of A, right? So if you have A inverse given in terms of polynomial of A, Like for 3 cross 3, this A inverse for 3 cross 3. If A is a 3 cross 3 matrix, this is something A, B, C, D, E, F, G, H, I. So for that, if in the problem it is given that A inverse is equal to something A square plus B times A, not that same A, but okay. So basically when A is written as something, let's say A, B, C, D, E, F, G, H, I, right? This is matrix A. And you have got A inverse in terms of polynomial of A. In the question if it is asked that A inverse is equal to PA square plus QA plus something CI, RI, like this, right? If you prove this, there you use characteristic equation, right? What is it? You just do A minus lambda is equal to 0 and put A equal to I. Sorry, put lambda equal to A. Put lambda equal to A. That will be the characteristic polynomial, and then just multiply by inverse both the sides. Multiply. So this is the standard type problem, and in that you remember for a cubic, like for a cubic, this will come out something like this: A cube plus A cube. It will be, I think, minus. Yeah, it will be A cube minus. This will be trace of A into A square, then plus some constant into A, then minus determinant of A into I equal to 0. This is the characteristic polynomial for a cubic. The coefficient of A square will be trace A, negative of trace A, and the coefficient of this will be equal to determinant, right? So hoping that you have understood. Moving to the next and last segment, which is Cramer's rule. And Cramer's rule, see, this Cramer's rule is every year there is one problem from Cramer's rule in your exam. Rule is very simple, extremely simple. There are some facts which I am going to, okay, I will not prove. I don't have that time to prove. I'll show you. So first we'll do it for non-homogeneous equation. Non-homogeneous equation. So we are talking about solution of planes. We have equation in 3 variables. So let's say we have system of equation. We have system of equation a1x, b1y, c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x, b3y, c3z equal to d3. So we have been given 3 equations, and we have to find out that what is the behavior, like do we have solutions, do we have infinite solution, do we have finite solution, do we have no any solution at all. So for this analysis we use Cramer's rule, right? So we define some standard determinants here, and guys, if you know, this is what, this is a system of planes. We have been given 3 planes, so we have to find out how are they behaving. So we define a matrix, a determinant D first, which is made out of the coefficients a1 a2 a3, b1 b2 b3, and c1 c2 c3. This is D. Then we define D1. What is determinant D1? Start with D1, D1 D2 D3. Then since we are writing D1, so forget the coefficient of A, write B and C in order: B1 C1, B2 C2, B3 C3. This is D1. Then D2, so forget about Y. So forget about the Y, and this will keep on shifting by 1 position. So D1 D2 D3, rest all will be in order AC. So A1 C1, A2 C2, A3 C3, and then similarly D3, D1 D2 D3, and then for C it is A1 B1, A2 B2, A3 B3. Right. So for this system we define D, D1, D2, D3, and this is important to understand how we are writing that, because in this part, guys, questions are direct formula based. You don't need to have the knowledge in full depth. The formulas are sufficient. After you are done with these all calculations, there are few standard results that you need to know for this non-homogeneous system here. And what is that? The first thing, if D is non-zero, then unique solution will be there. Okay, there will be unique solution. If that D discriminant, if that determinant D is non-zero, they'll be having unique solution, and also there will call consistent system. Consistent system. So we call system consistent if we have solution. Right? If we have solution, we call it as consistent system. And second, if D is equal to 0 and D1, D2, D3, like in all of these three, at least one is non-zero, then no solution will exist. There will not be any solution, no solution, and this will be called inconsistent system. Inconsistent system. Inconsistent, that's all. If you get D equal to 0 and any one of D1, D2, D3, like not 2, 3, not all, anyone, even at least one becomes 0, that system will be called inconsistent, no solution. The third one, if D, D1, D2, D3, if all are simultaneously 0, then this will have infinite solution. Infinite solution, and this will be a consistent system. Consistent system. See, whenever we have solutions, doesn't matter finite or infinite, that will be a consistent system. If we have no solution, that will be inconsistent. Now, this is when we are dealing with non-homogeneous system. If we have homogeneous equation, if we deal with homogeneous equations, right? So basically, in homogeneous equation, we'll have a1x, b1y, c1z equal to 0, a2x, b2y, c2z equal to 0, and a3x plus b3y plus c3z equal to 0. So in this you can see D is same, D is still the coefficient determinant a1, a2, a3, b1, b2, b3, c1, c2, c3, but you see d1, d2, d3 all are 0. Why? Because if you see from that slide, you see the small d has become 0. So we have entire row, entire column equal to 0. So if entire column is 0, determinant value is 0. So d1, d2, d3 will become 0 for what system? For that homogeneous system. So here we have only two cases. If D is 0, right? If D is non-zero, in that case, first case, like there are only two cases. It all depends on D. So if D is 0, if D is non-zero, then we'll have unique trivial solution. Unique trivial solution. Now by solution, what do we mean? You see here in this system, this x value is d1 upon d. This is x. Y value is d2 upon d, and z value is d3 upon d. This is value of x, y, and z. The value of x, y, and z. So that is how you can relate. That is how you can relate that if d is non-zero, there will be unique solution. If all are 0, so basically you will have 0 by 0 form. 0 by 0 there can be infinite results. And if one is 0, other one is non-zero. So if one is 0, other one is becoming infinite, no solution will exist. So now in the homogeneous case, you see d is non-zero. So basically what is x? X is d1 by d, y is d2 by d, z is d3 by d. So if we have this, you see, if d is non-zero, then we will have unique trivial solution. That means we'll have x, y, z as only 0, 0, 0. Right? Because this is non-zero, this is 0, so that will be 0, 0. And if d is equal to 0, in that case there will be infinite solution. Infinite solution. That will include this also. It will be including trivial and non-trivial. Non-trivial. Right? And in both cases, this system is always consistent because guys, in both cases, we are having solution. So this homogeneous system is always consistent, and this is the thing, non-trivial. This is what you are going to be asked most, that what is value of some given thing for which the system is having non-trivial solution. See, this is trivial, only 0, 0, 0 when d was non-zero, but when d is equal to 0, it will have infinite solutions including trivial and non-trivial. And see, if you see 30 questions of Cramer's rule in JEE Main, 25 will be based on this. I can guarantee you. 25 questions will be based on non-trivial. Exactly one thing, put D equal to 0. Right? You just have to see if your equation is homogeneous or not. Very easy. Like if you are done with these conditions, if you remember these conditions, direct problems are the exams, direct questions, no exceptions. Okay, so let's solve that. And this matrix method, guys, basically that equation, that equation that we have written, a1x plus b1y plus c1z equal to d1, a2x, b2y, c2z equal to d2, and a3x, b3y, d3z equal to d3. So basically we write this equation as a product of two matrices, a1, a2, a3, b1, b2, b3, c1, c2, c3 into x, y, z is equal to d1, d2, d3. So this becomes a system a into x equal to b. So x is nothing but you multiply by a inverse both the sides. So x is nothing but a inverse into b. So by this also we can find out the solution. X will be equal to a inverse multiplied by b. So this is the matrix method. In your board exam, you must have seen in your boards, it will be helpful. So you see all the questions are direct here. Just read. I'll only read the problem. What is the question? Says minus x plus y 2z. You see it is 0 or it is 1 here and it is 7. Let us know the set of all for which system is inconsistent, and has to be the set of all for which system has infinitely many solutions. So you have that fixed case. System is inconsistent, right? So for that you have to find out D, D1, D2, D3. When is it inconsistent? This is non-homogeneous. This is non-homogeneous system. When is system inconsistent? When we have D equal to 0, but one of D1, D2, D3 non-zero. So you find out everything and then just write your answer, right? Just for example, I'll show you here. Let me write equations again. So what is D, guys? What is D here? Minus 1, 1, 2, this is 3, minus a, 5, and 2, minus 2, minus a, right? This is D. So this D should be 0. This D should be 0, right? If you are finding for inconsistent. So for inconsistent, this D will be 0 and one of at least one of D1, D2, D3 should be non-zero. So you will solve for D equal to 0, you will solve for these non-zero. There has to be like too much calculation, but you will get it, right? Second one says infinitely many solution. So for second case, for infinite, what to do? You have to check for D equal to D1 equal to D2 equal to D3 equal to directly 0. The questions are going to be super direct. There's nothing there to solve here. In the following linear equations has no solution, guys, no solution. And you see this is also a system where it is non-homogeneous. So if it has no solution, so that means inconsistent. So D has to be 0 and at least one of D1, D2, D3 has to be non-zero. Same process. So you can just try on your own. There is nothing new. You can just try on your own. You will get answer. Next one, alpha, beta, gamma. Then the system equation has. Now for that, see alpha, beta, gamma is given 2 pi. So for that, this is a homogeneous pair. So we'll calculate D. What is D? 1 cos alpha, cos beta. Then second one is cos gamma, cos delta, right? First one is cos gamma, cos beta. Let me correct it. This is cos gamma, cos beta. Then this is cos gamma, 1 cos alpha. The next one is cos beta, cos alpha 1, right? Has what type of solution? So alpha, beta, gamma is given 2 pi. Alpha plus beta plus gamma is given 2 pi. So what to do here? You have to solve this 1 cos gamma, cos beta, cos. So you see this is cos gamma, cos beta, cos alpha. Symmetric determinant. What is the value here? ABC, right? Plus 2FGH. So 2 cos alpha, cos beta, cos gamma minus AF square. So minus AF square, cos square alpha, cos square beta, cos square gamma. Is the thing. So we need to solve this. So for that, now this is 1 minus cos square alpha. So that will be equal to sin square alpha. And to simplify it, it's given that alpha plus beta plus gamma is 2 pi. So alpha plus beta plus gamma is 2 pi. So what will be 2 pi minus gamma. Okay. So I think we have to convert product to sum. So 2 cos alpha cos beta, I can convert it to sum. What is that? This is cos gamma multiplied by, what is it guys? What it will be? Cos gamma into, this is cos 2 cos alpha cos beta. This is cos alpha minus beta plus cos alpha plus beta minus cos square alpha, cos square beta, cos square gamma. So this is 1 plus. Now cos alpha plus beta is what? 2 pi minus gamma. So 1 plus cos gamma into cos alpha minus beta. And this is cos alpha plus beta will be again cos gamma, right? Because alpha plus beta is 2 minus gamma. So this will be cos square gamma minus cos square alpha, cos square beta, cos square gamma, right? So this will cancel out, this cos gamma, right? So from here you'll get it that this is 1 plus cos gamma into cos alpha minus beta, because this will cancel out guys, cos square gamma, this will cancel out. So we'll have cos alpha minus beta minus cos square alpha minus cos square beta, right? Now what we can do, we can write 1 minus cos square alpha is sin square alpha. So cos gamma cos alpha minus beta plus sin square alpha minus cos square beta. That is itself a formula. What is cos square A minus sin square B, right? This is cos gamma cos alpha minus beta minus. Now if I subtract these two, sin square alpha, so this is cos square beta minus sin square alpha, so it is cos beta plus alpha, cos beta minus alpha. So we'll take cos beta minus alpha common. So what is it remaining? We'll take common. This is cos alpha plus cos gamma plus cos beta plus alpha, right? So when you add these two, so you will write cos gamma beta plus alpha plus gamma, that will be 2 pi, right? So it will be there is a negative sign guys, right? Okay, there is a negative sign. When you see cos C minus cos D, so you'll have cos beta minus alpha into, this will be sin alpha plus beta plus gamma by 2, twice or something. Now that will be what? That will be 2 pi. So sin pi factor will come out. Now what is that? 0. Sin pi factor will come out. That thing will be 0. So you see that D is equal to 0. So it will have infinitely many solutions. Now this calculation here was lengthy, was slightly lengthy. But again, the funda of the problem, this is Cramer's rule. Same thing. Just find D. Everything will be decided by D, right? If it is homogeneous, you see most of the time if you are homogeneous, you see this is non-homogeneous again, has infinitely many solutions. So what to do here? Put D equal to D1, D2, D3, everything will be equal to 0. So what is D? D is 2, 1 minus 1, 1 minus 1 minus 1, and 3, 3 beta. That will be equal to 0. Now what is D1 guys? D1 is 3 alpha and 3, then this is 1 minus 1 3, and this is minus 1 beta, minus 1 and beta equal to 0. So from here we would have got value beta, so that beta you can use here, you'll get value of alpha. So that's all, game is over, right? The only two you solve for D and D1, game is over. You don't, because if they are saying that this has infinitely many solution, then this is equal to what? So that's all. Just by solving d equal to 0, d1 equal to 0, you got the value of alpha and beta, game is over, right? We can verify, you can verify that d2 and d3 are also 0. You can verify that, but it's not required, right? So all the questions are similar, guys. Set of all values, the random always has a solution, unique solution. Just put non-zero, right? Non-trivial solution. Non-trivial solution here, what to do? Put d equal to 0, right? Everything here you see, all questions are alike. All questions are alike. So you see the number of questions, guys. You see the number of questions. These are questions from 2021. You see, every time the system is same, has no solution. Has no, what type system is this? This is a non-homogeneous system. So you put d equal to 0 and at least one of d1, d2, d3 non-zero. You see, every time the questions are, guys, exactly. You see, from 2021, these many questions are there. And the questions have only one pattern. I'm not going to solve, right? It's up to you. You have to practice Cramer's rule. All the answers are marked. You see, all the answers have been marked. I have marked all the answers. Like here, all the answers are marked, right? All these green values are the answers. So I want you to practice these questions because there is nothing new in Cramer's rule. It's directly formula based results that are going to be there in your exam. So I want you to practice all these questions which I have left for you. Practice them, check your answer. If you don't get it, check solutions on the internet, but make sure that you practice all these questions. Cramer's rule is nothing. It's directly based on those conditions. You just solve them, you'll get them. It's only about calculation of determinants that takes time, right? So that is all with determinant matrices. We'll meet in next lecture with some other topic. Till then, keep learning. Bye bye.